All right, so I guess we'll just get started. Uh, so in this video, we'll just be going over a conversation that Will Duffy had with Bell. Um, and I feel like it was a really good conversation that highlights, how Will Duffy is actually not being 100% honest when, you know, looking into this subject of the shape of the Earth, especially with the final experiment that he's bringing to the table. Um, So, so yeah, we'll get into that in a bit. Before I get started though with the video, I wanted to go over a couple of videos actually. Is that one and then another clip of him admitting or him bringing up the forced align experiment and basically talking about funding it. So we'll be going over that as well. So, but again, before we get started, I did wanted to go over something real quick. Um, by the way, Boomy, BG, Angela, JC, thanks for being here, and everybody else in chat, thanks for being here. So, yeah, let me see. I wanted to see if I can screen mirror my my iPad screen. I wanted to test something out and see if I can go over it real quick before I get started. Okay, so. Okay, so let me just put this aside or hide it. So I guess so. This is the whiteboard, right? The whiteboard and pen. So if you guys could see it on the screen, I just wanted to go over a couple of points regarding constant motion on Earth and why you need acceleration to overcome the constant force of the Earth to basically recreate buoyancy or the displacement of matter. So, for example, if we had a container. Oh, okay. So if we had a container. Oh, forgive me. I'm a little shaky, as you guys can see. Let me see. Bear with me. See if I can do straighter lines. So, okay, we have a container, right? And there we have something solid in there. For example, we say there's air, all over this container, right? And then we have something solid, for example, right? We'll color that in, right? Now, if there are no forces acting on this container with air and a solid, right, then nothing's gonna move, nothing's gonna displace, right? Because the rock's not gonna move itself without a force or without anything acting on it. As soon as we introduce a force and start moving the container, for example, in this direction, right? When we start moving the container in that direction, what's gonna happen is the container is gonna start to move in that direction. And then the air that's going to be pushed by the container that's moving in that direction is not going to be dense enough to push the rock, for example. So the rock is going to appear to move in the opposite direction relative to the container. But that's because the container, it's moving in this direction. So let me see if I can erase this. There we go. So again, with the force acting in this direction, for example, the rock is going to displace to this direction again. It's going to be pushing back because, the resistance to the force, right? And that's going to give you a weight measurement on this side. And again, this is a constant force, for example, because there's no other forces acting on it. So this will be a constant force. The matter will push back in this direction. Again, relative, the opposite direction. To the force that's being applied. So when we're on Earth, where's the, okay. So when we're on Earth, for example, this is Earth, there's an upwards vector, right? Or a force, the globe Earth will call it a normal force, right? So, and we have a container on Earth, like a van or something, right? With a box with some wheels, right? Now, this container here, it's connected to the Earth. So in other words, it's already experiencing a force, an upwards force. So we'll say that this force of the Earth, for this demonstration, for this explanation, I guess, we'll say it's 1,000 miles per hour. Well, that's horrible. So, so we'll say it's 1,000 miles an hour, right? So if we have like a bowling ball, for example, here, right? Like that. Then that bowling ball is gonna feel that upwards force. So it's gonna, it's gonna be pushing back. It's gonna be resisting this upwards 1,000 miles per hour force of the Earth, in my opinion. And again, I'm using 1,000 miles per hour because, in my opinion, that's at least the speed that the Earth it's moving, in my opinion. Because why? Because there is a fast deceleration rate that people like to say, the 9.8 meters per second deceleration. In my opinion, that indicates that the Earth is moving a pretty fast rate. So I would say it's moving at least 1,000 miles an hour. It could be moving faster, for all we know. But again, it's a constant 1,000 miles an hour, right? So the bowling ball here in this case is resisting, in other words, its upwards force. So there's a because of inertia, again, is resisting that upwards push already. So if we start, let's say it's already all moving together. Now we introduce a horizontal constant motion. We'll say 100 miles per hour in this direction, right? Now, the bowling ball inside this container, this bowling ball now is experiencing two forces. So it's still experiencing the 1,000 miles an hour upwards force, but now we're adding this 100 mile an hour constant velocity in the horizontal. So now there's people saying that, well, why doesn't the bowling ball displace, back when you add, when you're moving at 100 miles per hour horizontally? Why doesn't the bowling ball? So these people that ask that question want you to disregard the fact that this bowling ball is also experiencing the upwards vector of 1,000 miles an hour. So why would they expect for the bowling ball to displace when 100 miles per hour constant velocity when it's experiencing a greater constant velocity in the upwards trajectory? In other words, a greater force. So why would people think that the I guess the lower force, I guess, or the lesser force in this case, can overcome the greater force, which will be the motion of the Earth? When you have two constant velocities acting on the same object, then the greater force is what's going to affect it the most, which will be the upwards vector in this case, which is why something that's moving at a constant horizontally is not going to get displaced back, because there's a greater force displacing it down in this case, which is why you need to constantly accelerate, to displace the matter within, because it's already experiencing a constant force, which will be the Earth. Again, that's why I say in Freefall, for example, you don't need to overcome a force. So you just need constant velocity, and that's what gives you the displacement, because matter has inertia. Again, you would have to claim that an object that's in motion, for example, in constant, let's say this container was in constant velocity to the right with no forces acting on it, for example, we'll say 100 miles per hour, right? Constant velocity, right? They want you to believe that matter doesn't have any resistance. Therefore, if there's something inside this container also being pushed by the container, that object is not going to have any resistance, and it's literally going to move itself perpetually, forever. In other words, that's what they want you to believe, that we live in some kind of frictionless environment, that matter doesn't get affected by it. And we all know that obviously we don't live in a frictionless environment. So there's always going to be a resistance. There's always going to be a pushback when we're adding a force. Again, this is part of the third law of motion. For every action, there's an equal and opposite reaction. And that is the resistance of matter, the inertia of matter resisting the force. So again, this is just a quick little thing I wanted to go over again regarding two constant velocities on Earth, and why matter doesn't displace unless you're constantly accelerating, is because, again, you're having to overcome the greater force when we're just dealing with a constant velocity. And if you want to overcome that greater force, then you need to constantly accelerate. You need to constantly increase the force to be able to overcome that, again, when you're connected to the Earth, because you're having to overcome that upwards vector that's already there, the greater force, in other words. So it's literally that simple. And I just wanted to go over that real quick, and we could probably get started with the video now. Just erase this. I guess we just keep that. And minimize this right quick. Okay. So again, we'll get started with the video, with the first video. Let me just see if anybody else is in the chat. Skilly, Imran, that bitch Jules, Sean. What's up, everybody? Okay, so let me get started with the first one. Hopefully after there's some time, I'll open up the panel for anybody that wants to come on. So hopefully there's enough time for that. But let me see here. Okay, we'll share this. All right.
Who was that a minute ago? All right, mate.
Sorry about that. Am I here?
Go, sure here. Yes. Who was that just came in a minute ago?
My
Safety checker.
I'm getting an echo. Hold on. There we go. Sorry, that my computer was signed into my wife's account.
Well, all right. So it's going to be obvious. I don't hope this doesn't put you off, mate, but you won't be able to see me. My camera. Hello? Danielle Duffy has just joined. Safety checker.
I'm getting an echo. Hold on.
I don't know what happened there. Sorry about that.
There we go. Sorry, that my computer was signed into my wife's account.
Well, all right. So it's going to be obvious. I don't hope this doesn't put you off, mate, but you won't be able to see me. My camera's ascribed to the OBS, and I'm not a tech guy, so trying to figure that shit out, it's just not going to happen for me. So you have to put up with it. I'm just going to screen share so people can see your face, and instead of mine. Two seconds. So how are you doing? You all right?
Yeah, I wanted to tell you a couple things. One is I actually like your accent.
Right.
So for the people complaining out there, I think they need to take their complaints somewhere else. And I've actually been to Scotland.
Nice.
It's a beautiful place. I feel like I could live there.
I'll tell you what then, well, you can swap with me and I'll go and live in your house then, right? Because I'm sick and tired of the shitty grey sky here. So if you want to live here, that's good.
It was, hey, when I was there, it was very green and very beautiful. And I like history, and there's obviously a ton of history there. So my roots actually go back to Scotland on my dad's side and back to England on my mom's side.
Right, nice. Nice one. Well, where do you live now then? I don't mean your address. I just mean, you know, what area you in.
Yeah, no. I'm in the United States. I'm in Colorado.
Oh, nice one. So you get the best of both worlds then, a bit of skiing and some sunbathing.
Yeah, we definitely get a lot of sun and a lot of snow.
Ah, good. So you ready for the interrogation?
Yeah, so what I was going to tell you is I want to start by talking about the final experiment, but if you want to talk about other things, I'll talk about whatever you want.
No, I mean, I would just like to know, I mean...
For anybody curious, this conversation happened a few months ago, probably actually like 4 or 5 months ago, probably. I'll post the link in the video for anybody who wants to check it out. So, but yeah.
Who put my name forward?
I did.
You did? Why?
Yeah.
Why? Why?
So I invited 24 flat earthers and 24 globe earthers, and I picked who I thought were the top 24 from each side, and you made the cut.
All right.
So it's a compliment.
Oh, nice one. So I was in the list of flat earthers then?
Yeah.
I don't think it's much of a compliment to be called a flat earther, you know. You ask me, you know. But yeah.
But I'm not a flat earther.
What are you?
I'm just a guy. I mean, the Earth's obviously no flat.
It's a globe, you mean?
No, it's certainly not a globe, but it's no flat either. Flat Earth and globe Earth are just as ridiculous as each other.
So the only two models I know of, I can put it this way, would be water on the Earth is in the shape of a ball, or water on the Earth is flat. So are you in one of those two groups?
Well, flat water being levels and orientation, it's the result of a force acting. It's not really a shape, is it? Water has no shape, although water in freefall you could have as a sphere, obviously, when there's no force acting on it. But, you know, flat water is a spherical water. I mean, that's totally irrelevant as far as I'm concerned. Levels, you know what level means?
Yeah, the globe says that, you know, water is level, and the flat Earth side says water is level, and so the definition of level does account for both models.
But that's the problem, isn't it? Well, I mean, language and definitions, you know, to define something requires you to root it in something objective. So for anybody to say level, you know, is then, you know, equal distance from the center of a circle to the outer circumference of a circle, that's a mathematical definition. It's not a real world practical application.
Okay.
Well, I mean,
Again, just because the globe Earth has an explanation for what level means, you know, that doesn't mean we disregard, you know, practical reality and what actual level means, which is horizontal, which means no deviation in elevation from any starting point to any other point. So again, it doesn't matter if you have an explanation or a definition for level. If it cannot be demonstrated in reality, then it's not true, you know.
I just want to know a wee bit. I mean, have you researched anything at all?
Yes, I have.
But you put me in a list of flat earthers, although I've confessed and said that the Earth's demonstrably no flat. So your research is a bit shit, mate.
It's okay, because the 24 people that I invited that are not globe, they all have something in common, which is, in their view, the water on the Earth is flat.
Mm-hmm. Well, I would say the water's level. I don't know about flat.
Yeah, but the globe side says the water is level as well.
But so in a globe, what's the definition of level? What does it mean?
We could look up a dictionary definition if you want.
Well, I don't know if you know much about me, mate, but I don't cite things from external sources. I'm pretty much a practical, hands-on guy, and I like to reason with people at a realistic level and get to your own reasoning rather than going to other people's reasoning. You know, so I mean, I know that there's a generalization that people go with a certain mold, if you like, which is fine. But when it comes to talking to me, I like to engage with the person at a level between you and I and see where your reasoning is, if you're up for that.
Yes, I do want to start by talking about the final experiment first.
All right, just go for it. Go for it then.
Okay, cool. So obviously there's a lot of debates about the shape of the Earth. And it's fascinating to me that something as simple as shape, because again, we start learning shapes when we're about 2 or 3 years old. So we understand shape from a very young age. So something as simple as shape with an object that's arguably the biggest object that any of us have seen and touched and experienced, that we have a debate. And so I like to come up with big ideas. And I was like, what if I could come up with an experiment that would settle the debate, that would end it? And so I came up with the final experiment. And what I came up with was something, this is important, a lot of people don't understand this. I came up with something that prior to me saying what the final experiment is, both sides agreed. Not necessarily everybody, but everybody I could find that talks about it, they agree. There's a lot of debates that there's not agreement on. Like one side will say, well, if we shoot a laser over water, that proves that we don't live on a globe. And the globe side's like, no, that doesn't. You're not accounting for certain things. And so the thing that I found that both sides agreed on was what the sun does in Antarctica. The globe side says there's a 24-hour sun, meaning if you're far enough south at the right time of year, the sun will never set. It'll just do circles in the sky. Yep. And the flat earth side said, well, no, that doesn't work. There can't be a 24-hour sun. The sun must set in Antarctica. And so the final experiment is very simple. We go to Antarctica this December, which is the southern summer, and we simply look in the sky and see what the sun does. Yep. And if there's a 24-hour sun, we live on a globe. If the sun sets.
Not only does this experiment completely assume what the sun is and what it does, it also has to assume or push both of these models. They're literally pushing the globe Earth model, obviously, and then the AE Gleason's map, obviously. Mm-hmm. So they're pushing both of these models to basically go against each other. And if the sun observations, again, don't fit these models or one of the models, then basically that proves the other model. So basically, they're kind of pigeonholing people into both of these models first, which again, nobody, first of all, doesn't know the dimensions of the Earth or the layout of the continents or the exact size of the Earth. But they want to push both of these models, which claims, which obviously have a layout and they're basically maps. But you also have to assume what the sun actually is and what it's doing. So it's faulty reasoning. It's an observation, not an experiment, and it doesn't prove nothing about the curvature of the Earth or the lack thereof. Mm-hmm. Again, it's just an observation about the sun, which is fine if people want to observe the sun and make assumptions about the sun and make assumptions about where they think they are on Earth. So you have to make a lot of assumptions to basically, which at the end of the day, I don't know what the fuck it's going to prove. I don't know what the fuck it's proving, Again, it's going to either prove, it's going to debunk these models, but at the end of the day, we know that reality is not a model. We know that these maps are probably, the Gleason's map most likely bullshit. Obviously, the globe Earth is bullshit. They're just a projection of each other, both of those maps. So again, it just doesn't make any sense, in my opinion.
We live on a flat, stationary plane.
But that's you setting those boundaries and setting those rules. Well, that's a bit unfair, is it not?
It really wasn't me. I'm just the one that named it and I'm paying for it. It was Dean Odell, it was Dave Weiss, it was Jaron Campanella, it was Austin Whitsitt, it was Nathan Oakley. The list goes on and on. I posted videos of all of these people tweeting what I just said for some portion of it.
Well, you can discount me from that one. And you know, in regards to the final experiment, you know, I would say a couple of things. It's not an experiment, right? It's an observation. And you're a bit late to the party, Will, because for the last almost 10 years, I have been screaming for an actual measurement of the Earth, which would be on both models. Both models agree that they have a plumb reference. You understand what that means?
Yes.
So in any model, plumb is plumb, right? Now, if you construct a level perpendicular to that plumb over the surface of a body of water, then you will get a direct measure if the Earth is curving beneath that structure. So if you build perpendicular to plumb, say over a mile or 2 miles, perfectly level over a surface of a body of water, you would get a direct measure of the curvature beneath that structure.
Okay, why haven't you guys done that?
Because
So what Dell's talking about, I'm pretty sure all of you have seen this, but let me share my screen. Should have had this ready. So a direct physical measurement will be something like this. Again, so here on the left, again, this is what reality would show, you know, water level to be. So if we went to a giant lake, again, a level structure, if we were to build a level structure, again, perpendicular to the plumb, which would be the starting point here, you know, because regardless whether you live on a globe or a flat earth plumb, you know, both models, you know, will have a plumb reference. And building perpendicular to that plumb, again, staying 90 degrees, will build a perfectly level structure. This will be the forced line experiment, in other words. We're forcing the line with the structure, you know, so we'll have a level structure over a body of water. So this measurement, if the curvature is truly there, if the Earth is a globe and it's curving at 8 inches per mile squared, then we should see that deviation of the water, you know, deviating from the structure. So in 3 miles distance of the structure, there should be a 6-foot drop. And not only that, you know, that drop increases every mile relative to the previous mile. So by the 10th mile, there should be 66 feet of measurable curvature. So that's like a 6-story building. That's how much gap there should be between the structure and the water level. But again, we understand water doesn't have the physical ability to support itself, you know, like glue or like jello. You know, it always collapses and forms an equal surface, that being level, that being horizontal. So again, a physical measurement of the Earth, water in specific, again, is going to show whether the Earth does have convexity or if it doesn't. You know, but again, this would be the experiment that was probably referring to. So.
it takes land, the logistics are very difficult. Well, I'm not a guy that has a lot of money. There's not a lot of people in any of these, you know, YouTube, you know, I'm saying communities in inverted commas, because obviously that's going to take a bit of effort. But to me, you know, I think that it would be justified. The amount of traction that this whole discussion has, it's always been there in history. Then for me, why not build a scientific monument that can be left for generations to come, who can then witness this structure for themselves, rather than just an optical observation making assumptions about a sun based on 2 conceptual models, which I think is totally ridiculous. Because you have to understand, well, these models that you're talking about, the globe Earth and the flat Earth, are concepts. Do you know what a concept is?
Yes.
It's not a real thing.
Yes, but the sun is real, and Antarctica is real, and what the sun does is real.
Yes.
And so I think we should all want to know the truth at a bare minimum. We should all want to know the truth of what the sun does in Antarctica.
That's fine. I mean,
Again, to say that, okay, we should all want to know the truth when it comes to the sun and earth. First of all, I don't care about what the sun does personally. So I don't care about the truth of the sun. Because why? Because it has nothing to do with the shape of the earth. So to me, the priority is, exposing the globe earth lie, in my opinion, obviously. And that, looking at the sun, it's not going to tell us nothing about the ground we walk on. So again, the people that want to know the truth about the sun, fine, that's fair game, but it has nothing to do with the shape of the earth.
Yeah.
That's the thing. If your priority is exposing the globe earth lie, or, proving whether the earth is a globe or not, then looking at the sun is just a waste of time at the end of the day. Again, a direct physical measurement of the earth is what's going to show us. Now, somebody did put in the comments, I think it was Brenda, about, you won't be able to build a perfectly level structure that's 6 miles long. That's true. We're not going to get a perfectly level structure, but we could get it pretty close, over 97% accurate, and we can account for that as well. So this can be done,
Yeah, there's still a significant amount of curvature that should be measurable.
Exactly. So 66 feet in 10 miles, which again, 10 miles is not that long, when we're talking about the size of the earth, allegedly, right? So again, 10 miles is nothing.
Yeah.
So again, building a level structure, again, it's not going to be perfectly, 100% straight. That's obvious, but we can get pretty close, over 97, 98% accurate. And again, we can account for the small, inches or maybe even a foot that needs to be accounted for of the structure. But again, the curvature should still be there, regardless. So
that's as far as it would go for me. What does the sun do in Antarctica gives me no clue as to the full dimensions of this Earth. I mean, it's a red herring fallacy at the base level. Well, how can you determine the shape of the Earth you're standing upon by what happens in the sky above you?
It's very, very helpful. So let me tell you something. So number one, you just mentioned the dimensions of the Earth.
Yeah.
The final experiment has nothing to do with the dimensions. So maybe it's a small globe, maybe it's a large globe, maybe it's not a globe. It's nothing to do with the dimensions.
But you keep referring to this as if this is going to show that it's a globe. Now I need to know, for your reasoning, why do you think that's going to show it's a globe?
Okay, I'll tell you why. So as far as I know, maybe you're an exception here, but as far as I know, everybody that I would consider flat Earth has stated publicly that there is a 24-hour sun in the north. And so that means, again, a sun that...
Again, the people that made these claims are only making assumptions. So again, he asked them a really good question. What about looking at the sun proves to you that the Earth is a globe? Which is a great question. But again, he has to divert from answering that directly, because obviously there is no answer to that. Logical answer to that, because it doesn't prove anything. It doesn't prove whether there's a globe, or it doesn't prove whether it is flat or level, right? So he goes into, again, pigeonholing people into these models, because the big flat Earth channels are all pushing this Gleason's map. Now everybody has to basically accept it and basically battle with it. And so that's basically what's happening here. It's a debate based on two models. And again, it is a debate because, again, reality is not up for debate. Reality is what it is. But when you're presenting models, then yeah, you can debate models. This model versus this model, this explanation versus this explanation. That's exactly what we're seeing here. Mm-hmm. Again, it's a red herring. It's a false dichotomy, obviously, to present both of these models and battle them against each other based on the observation of the sun. So again, he's just literally pigeonholing people into these models.
It's a distraction too from having to actually physically prove the globe.
Exactly.
Just focus on the observation and that's it.
Yeah.
It's no, it's not even an experiment. It's just an observation. You still need to prove the globe physically.
Again, it's no different than when people would look at the horizon and say, "Oh, that's the curve of the Earth. Look, there's boats disappearing over the curve. It looks like they're being covered by the Earth, so that must be the curve." So technically, they're taking that observation and calling it an experiment now of curvature. Like, we know that's retarded. We know that's bullshit. Obviously, that just observing something disappear at a distance is not an actual experiment. Again, because relying just on perspective alone, your eyes can easily be fooled. So again, same thing now with the sun. You know, observing the sun, again, it's not going to tell you anything about the Earth, but again, they're pushing this false perception of these models, and again, just battling, you know, explanations against each other, which again has nothing to do.
It does a circle in the sky.
Again, which has nothing to do with the shape of the Earth.
In the north, if you're far enough north at the right time of year. Now, if the sun does the same thing in the south at the opposite time of the year, but it does it in the opposite direction as well, I would posit to you that is exactly what would happen on a globe, and I don't know of another shape that would be possible on. And I especially think there is no flat stationary plane model that anybody could even concoct that would have a 24-hour sun in the north and the south going in opposite directions at the exact opposite times of year.
That's just your incredulity then. Well, you're setting those rules and making those assertions. Again, how do you get a measure of the Earth from the sun?
So I'm not measuring the Earth.
Right, exactly.
There you go. There you go. Like, I don't know what else you guys want to hear. I mean, there you go.
We're not going to physically.
We're not measuring the Earth. We're just observing the sun. So what the fuck are we? Why are we pushing this as the final experiment to prove or, you know, disprove the globe? You know.
Again, it's an observation of the sun, but it doesn't prove anything about the ground they walk on.
Yeah, exactly. Again, the path the sun takes. Again, what the sun actually is. Are we looking at the actual sun, or are we looking at a reflection of the actual sun? You know, do people actually believe that the sun is actually there floating and it's creating, you know, it's there physically? Like, because I actually don't believe that. If you ask me, when we're looking at the sun, we're probably looking at a reflection of the sun, which again, at the end of the day, nobody knows. Again, this is just me speculating. You know, I don't know. You know, at the end of the day, you know, and again, it's completely irrelevant when we're talking about the dimensions of the Earth. You know, so.
I'm not trying to measure the size of the Earth.
You're taking two concepts and then making assertions about them.
Again, he tries to say that he's not trying to measure the size of the Earth. So it could be a big globe, a small globe, like you said earlier, but you're not measuring the curvature either.
Yeah.
Yeah, you're not measuring the size of the Earth, but you're also not measuring for curvature either, which is what we're asking for.
Yeah, he tried to sneak that one by.
You know, yeah, he tries to be sneaky with it again, but again, he doesn't prove curvature either. You know, you're not measuring for curvature either.
What I think the globe side does a little bit better than the flat Earth side is they make predictions and they're willing to state this is what we think, and then they allow everybody to go try to falsify it. They allow everybody the freedom to go try and test it.
Mm-hmm.
And so here's what I'll say. If the only thing that comes of the final experiment is we do go down there, we do find a 24-hour sun, and then what I would call the AE model or the Gleason model has to be completely discarded, and you guys all have to start fresh on a clean slate of trying to come up with a model. I think that's progress, and I'm fine with that.
Yeah, that's exactly it. Well, and again, if you had researched and known my history, you would know that from the very first day, that's exactly what I've been saying. I don't live in a model. What you're talking about are mathematical, conceptual models. Well, do you know what true scale modeling is?
No.
So in engineering, in the practical real world, we have true scale modeling. I'm surprised you've never heard of that, being in the business background or whatever. You know, true scale modeling means that if I have a premise, or I've created something, or I want to, you know, create something in reality, I first have to achieve it on a smaller scale. I have to actually construct a model utilizing the components and the tools, and make sure that things like, you know, stress, and that the structure's supportive, you know, all these variables that happen. Then I can start progressing from the scale model and scale it up to, you know, life size. That's called true scale modeling. So I'm going to ask you, well, can you true scale model a globe?
I honestly don't understand what true scale modeling is, so I'm not exactly sure what you're asking me to do. I can tell you this: I can't build a globe. I don't have the resources or the expertise to do that.
Well, true scale modeling, well, if I was to say, right, the Earth to me is a level plane, I can now demonstrate that from a very small scale up to a large scale, and I can utilize actual, you know, tangible aspects of reality, that being land, rock, sand, water, real world components, and I can demonstrate it in a realistic fashion. Can you achieve that with a globe Earth?
That's a good question. I don't know.
But you can't. If I gave you a ball and says, right, but well, make the ball float, make water stick to it, make people stick to it, yada yada, could you achieve it?
If I had some glue.
Well, exactly. Well, exactly. This is the difference. And you keep referring to like the flat Earth. I'm not a flat Earth. I'm not.
How are you gonna make water stick to a ball using glue? Even if you had glue, and even if you could use glue, like, how are you gonna make water stick to the globe around using glue?
The way he laughed at himself, he knows. That was a bullshit answer.
It's kind of funny, but yeah.
I'm none of these guys that you've listed. I've been on the outside and against these people for nearly 10 years. So, you know, I have to clarify with you, please don't refer to me as the same as these people, because if you look at the history and you speak to globe earthers, they'll tell you the exact same thing that I'm telling you right now. I've never been in with these model pushers, these, you know, fantasists, all these people that you've mentioned and that you've spoken about before. I've took this as an opportunity to try and, you know, alleviate some of that stuff, because I don't want to be lumped in with them, right? So again, when I'm reasoning with you as a man, Will, to try and help you to see your own reasoning and how I function. So when I say about true scale modeling, practicality, I live in the real world, so any claim that's made to me about the real world must be practically demonstrable. Would you accept that as sound reasoning?
I would not. Let me explain why.
Right.
How would you prove? Well, this is going to sound silly, but just work with me here, okay?
Mm-hmm.
Do you believe that your brain is curved?
What do you mean? Do I believe?
Do you think your brain is curved?
Well, I don't need to believe or think anything. I can see a brain. I can see the shape of a brain.
Well, hold on. Yours, though, not someone else's.
I don't have any beliefs. Why do I need to believe anything?
Do you hold a position where your brain is curved?
No, really, no.
Is it flat?
You're asking questions that are totally nonsensical, Will.
I think he was trying to like pigeonhole Dell into making an assumption. So,
or that he does have beliefs.
You know, or that he does have beliefs. You know, I think that's where he was trying to get there. And it's like, well, first of all, my brain, for what I believe, you know, it looks like, it has nothing to do with the shape of the earth, first of all. Second, I think obviously he's using the example as in, again, you have to have beliefs, in other words. And it's like, well, I don't have to believe that I have a brain. I know we need a brain to be here, to be conscious, you know. So it's like, I don't know exactly what he was trying to get out of this, you know. So again, I can only think that he was just trying to highlight that you do have beliefs, you know, but at the end of the day, you don't need beliefs about when it comes to objective reality, you know. And again, the brain is physical, it's real, you know, it's part of the objective world. Mm-hmm. So again, we don't have to believe that brains exist, you know, brains do exist, you know, so yeah.
No. I honestly, I've actually put a lot of thought into this. So I believe that my brain is curved, but I don't know how I would demonstrate that or prove that to you.
All right. Well,
I don't know how you would prove that to me either.
Well, you're bringing it to me. So what I would say, okay, if I was to try and say to you, I would say, well, look, these brains here are real things that we can observe and we can access three-dimensionally, and I can hand it to you and you can look at the brain and you can see the brain. Then I would have to say, why would you think yours was any different?
Well, again, that's an assumption, right? And I think that would be a faulty assumption to say if something follows a pattern, the next one must follow the pattern.
But the way my mind works well is I'll just crack it open and see what it looks like. I don't have to believe anything. You're bringing propositions to me that don't require my belief. I don't have beliefs.
How about this one? Do you believe that the moon is curved?
Well, I can see a circle in the sky. I don't believe anything.
Do you believe it's a sphere?
I don't believe anything. I can see a circle. Well, I mean, you're laughing, Will, but this is the problem that's going to happen, Will, because I'm going to help you to see the fault in your own reasoning. Right? I can see a circle in the sky. That's what I see.
Okay, but do you see a sphere in the sky with the moon?
Well, listen carefully. I see a circle in the sky. That's what I see.
Okay. My point is this. It's going to be very hard for you or me to demonstrate a lot of things about our world.
Like?
Whether it's something in our own body, like our brain, something that's in the sky, like the moon,
but no, Will.
Big as the globe.
No, Will. Because the things in the sky I do not have three-dimensional access to. Brains and skulls I have three-dimensional access to. So you're comparing two different things. You're comparing apples and oranges. The stuff in the sky, I do not have physical access to those things. Do you have that?
No, I do not.
Do you have physical access to brains and bodies and skulls?
Yes.
Yes. So that's the difference.
Okay, I do agree there's a difference, right? And so what I'm doing with the final experiment is I'm trying to take what we have access to, which is Antarctica and the sun, and trying to help move the debate forward.
I don't know how, though.
Well, here's how. I'm convinced now, because it's been months, that there is not a single possible model that's a flat stationary plane that can account for the 24-hour sun in the north and the south that go in opposite directions, because if there were, someone would have already provided it.
Mm-hmm.
So if we can figure out something that's an impossibility and falsify a model, I think that's great. Now,
brilliant, Will. Stop. That's excellent, right? Because I'm going to help you. I've falsified the globe model.
You falsified the globe?
Yes.
Tell me how.
The globe model requires physical downwards acceleration. Correct?
If you're talking about gravity, I would say yes.
Yes. Well, there is no physical downwards acceleration.
And how do you know that?
Because we've done various physics tests to show it.
So real quick, let me see if I can share. Something like this. Actually, I can just close this. So the fact that there is no physical downwards acceleration that can be detected on a globe falsifies the whole globe Earth model, because the globe Earth requires that people believe objects accelerate down in free fall. Why? Because again, if the Earth is a globe like we're told, like this, right? And objects, when you release an object, right here, for example, and the objects don't accelerate down towards the Earth, again, because they claim that there is a gravitational field, that flows down towards the center of the Earth. So that, that gives, the acceleration of objects in free fall, the vector, based on this idea of a downwards acceleration. If we could prove that objects don't accelerate down towards the Earth, and it's actually the Earth moving up towards the objects, that would mean that from a globe Earth model, up if the Earth is moving up relative to you on Earth, that would mean the Earth is moving up in this direction, every direction away from the center. If the Earth is moving up in every direction away from the center, that would mean that the globe Earth is literally expanding. It's literally growing by the second into infinity, which obviously it's retarded. The Earth would literally just explode, within seconds, literally. So again, debunking that there is no physical downwards acceleration in freefall falsifies the whole globe Earth model, because again, they require this belief in this downwards acceleration again that doesn't exist. So just wanted to highlight that. What's this?
We use accelerometers in various forms, whether it be digital or analog. You can do this right now, Will. Get yourself your phone, get an accelerometer on it. As you hold that phone, it registers 1G. As you drop that phone into freefall, it registers 0.
Sorry, I'm a comedian. My phone says 5.
I know.
I'm just messing with you.
No, that's fine. Well, I'm messing with you. You're a comedian. Well, the fact is, and this is the problem that's coming for the globe, right? People like me now have exposed this, and it's spreading, right? This is no flairfs or globe debates, morons debating each other about conceptual gibberish. This is direct real-world physics that every single person can test. It's a fundamental fact, Will. There is no physical downwards acceleration. No such force exists.
So I'm just asking you questions because I'm not a physicist here.
Cool.
I've watched videos of, items being dropped.
Yeah.
In like a vacuum chamber.
Yes.
And so what is going on there?
Well, when you drop some stuff in a vacuum chamber and you remove air, both of those things lose momentum at the exact same rate. If you attach if you're talking about the bowling ball and the feather in the vacuum chamber, okay? Now the claim is gravity is a force that acts downwards towards the Earth that accelerates things to the Earth, correct?
Yeah, that sounds right to me.
Right. Now, when we utilize analog and digital accelerometers, they detect the presence of force. That means when there's a change in a force acting, these devices detect the force present and the direction that the force is going in. Okay? So the bowling ball in a vacuum chamber, if you attach an accelerometer to that bowling ball, and there's a claim that it accelerates to the Earth, what do you expect the accelerometer to read?
I don't know exactly what an accelerometer is, but it's my understanding that the globe model has a very specific formula for gravity. So to me, it should be pretty easy to refute.
Yes, it is very easy, and it's very simple questions. Do you agree on the globe model that they claim there's a physical downwards acceleration towards the Earth?
Yes.
Accelerometers detect acceleration, the presence of force. Do you agree?
I don't know. This is the first time I'm hearing of an accelerometer.
Well, you have to take it on face value, and you can go and check this yourself, what an accelerometer does, right? Now, would you expect if an object, when I let it go, is claimed to accelerate towards the ground, that the accelerometer would detect that acceleration?
It sounds like it, yeah.
Yes, but it doesn't. It detects no downwards acceleration, Will.
What does it detect?
No.
Accelerometers detect a deceleration in free fall. So when you're holding, an accelerometer in your hand and it's connected to the Earth, or resting, if you're connected to the Earth and holding an accelerometer, it registers 1G. It's registering a force, a constant force. As soon as you release that accelerometer, it goes from 1G to 0. So there's a deceleration that happens when the force is removed, in other words. So again, the accelerometer doesn't accelerate, the force doesn't increase, which is what will happen when you actually accelerate the accelerometer. In free fall, however, there's a deceleration that happens.
No force.
So let me ask you a question just because I'm trying to understand your position here. Is your position that instead of things falling down, the earth is rising up?
That's a fact, Will.
Okay, so this is big. And I'm really glad that you said this because there's a lot of people who claim that the Flat Earth Society is like a fake organization.
Yeah.
And one of the reasons they say that is because the Flat Earth Society, I believe, says that the earth is moving upward.
Well, I would go and check that, Will, because the Flat Earth Society on their website, if you go to the facts section, FAQ section, and you go to that section, they say, no, we don't claim that. We claim the Earth's stationary.
Okay, interesting. I'll definitely look into that.
Yeah, you do that. So it's demonstrable. Well, the accelerometers detect the presence of a force acting upwards. It's called the normal force in the globular Earth concept.
How do you? So, what convinced you that the Earth was moving upward consistently?
Well, it started from globe earthers and flat earthers. So globe earthers claim gravity is a force acting downwards. And then you go to flat earthers who claim that gravity's fake and relative density disequilibrium is the cause. So do you know what that means?
No.
So you'll hear people at Flatzoid and some of these other flat earthers, quite a lot of them actually, who claim that, you know how when an air bubble rises through water and if say you've got a lead weight and you drop a lead weight in water and you've got an air bubble rising through water, they would claim that's buoyancy and density. You understand that?
Yes.
Right. So they claim that that buoyancy and density cause their own motion. Right? They're the cause of themselves. So I went and said, right, I'm going to test now to see if there is physical downwards acceleration. And I also made a prediction based on the flat earthers that when I drop a vessel, relative density is going to cease and we will not detect physical downwards acceleration. So just to clue you in on it, Will, to give you a better picture, and I can show you all these tests. These tests are there and you can recreate them yourself so that you know that it's real.
So real quick, so a simple accelerometer again. Will be this. Again, a container with water and an air bubble. Not only does the air bubble show when there is a force present, because obviously the air bubble starts to move, but the air bubble moves relative to the direction of the force. So it moves in the same direction the force is being applied. In this case, the force was being applied down, relative to the water bottle. So what I did here is that I accelerated this water bottle in the downwards acceleration, which again created a pressure gradient within the water, which again pushed the air bubble in that same direction. Again, this is a simple accelerometer. Why? Because we will always, 100% of the time, detect the acceleration. The air bubble will always displace relative to the direction of acceleration or the direction of the force that's being applied. So this happens 100% of the time. If you believe that this is not reality and that you can accelerate this without the displacement of the air bubble, then you're going to need to recreate an experiment to show that acceleration can happen without displacement. But again, that completely defies our understanding of physics, that we can all test. So let me see. So again, this is acceleration showing displacement. So when people claim acceleration in freefall, again, this is what acceleration actually looks like. Let me do the acceleration. Again, this one, I'm accelerating this container with a bungee cord here with a resistance band, you could say. So again, you can see the displacement when connected to the earth. The air bubble is being pushed up, again, showing you that there's a force up when I'm holding it because I'm connected to the earth. As soon as I release this and it's being accelerated down physically by this resistance band, we can see the inversion of the density and buoyancy vector. The density and buoyancy vector shows that the motion is up, that the force is up when I'm holding it. But as soon as I actually accelerate this whole container down, again, we get the inversion of the air bubble being pushed down now in the direction of acceleration and the steel ball appearing to move up. Again, there's not two forces acting on the air bubble and the steel ball. It's only one force, which is the motion of the vessel in the downwards trajectory in this case when I release it. Again, what's happening is when it's accelerating down, the container is pushing the water down with it, but again, the water's not dense enough to push the steel ball. So again, the container moves towards the steel ball, and that motion pushes the water in that same direction, which pushes the air bubble, because it's less dense. Again, the water's not dense enough to push the steel ball. So again, because of inertia, the container here moved towards the steel ball, which pushed the water, which pushed the air bubble down. Again, that's the displacement of matter when we actually introduce a force. Again, and it shows the force, again, in the upwards trajectory when it's just connected to the Earth. Again, when we put the container into free fall, however, we can see the air bubble, again, being pushed up when it's connected to the Earth. But as soon as I release it, and again, it's not being accelerated anymore, it's simply just falling, like people like to say, right? Or we can clearly see the air bubble not have a vector anymore. It's not being pushed up and it's not being pushed down. Again, it shows that there is no force present. And not only that, the steel ball shows a deceleration in the upwards trajectory, and it's moving in the opposite direction of the acceleration. If you're claiming acceleration of this vessel and it's pushing the more dense towards the direction of acceleration, that defies physics. That's literally the opposite of what we witnessed. Not only that, the air bubble shows zero motion and zero force in free fall, which again, if you're claiming acceleration, the air bubble should correlate relative to that direction of acceleration, because that's what happens 100% of the time, which again vanishes in free fall. There is no force in free fall shown by this simple air bubble that, again, should be pushed down if you're claiming downwards acceleration. Again, when I actually accelerate, like I showed in the previous one, the air bubble does get pushed down in the direction of acceleration. Again, this shows that there is no force in free fall. There is no downwards acceleration, period.
So if I take a vessel of water, Will, and I accelerate it towards the floor, okay? Like actually accelerate it towards the floor. What happens is there's an inversion of the liquid in the air, which means that the air now moves towards the ground and the water is now towards the sky. Do you understand?
Yes.
Right? So that's what happens when you actually accelerate things downwards. You get an inversion of the air and the water. When I'm holding a glass, the air's at the top and the water's at the bottom. If I accelerate it downwards, they reverse. The air now goes towards the ground and the water towards the top. Okay?
Okay.
So when I'm holding that vessel and I have an air bubble rising through the vessel and I have a lead weight sinking through the vessel and then I let the vessel go, those two things within the medium stop. The air bubble stops rising and the lead weight stops sinking.
Okay.
So
let me ask you a couple more questions, because I'm thinking through your model since this is the first time you and I are discussing this.
yeah.
So if the Earth is rising,
Yeah.
How do objects in the sky that are not connected to the Earth stay in the same vicinity of the Earth, like the moon or the sun or the stars? Why aren't we passing the moon up?
Because I would say, well, that, I'm a mechanic. My mind's mechanical. I do not think that there's any aspect of reality that is not intrinsically connected to another. This is heliocentric thinking, where we have a void, a vacuum, and we have objects separated from each other by a void. To me, that's preposterous. What we call the earth and the heavens, to me, are directly connected to each other. So the whole thing that we call the universe is moving as one uniform thing.
Okay, so interesting. So you think everything's moving up, not just the Earth?
Yes.
Okay, that seems difficult to test.
But it's
again, you would have to assume that the Earth is separate from all the lights and the sun, and it's all different systems, independent systems, and there's space between them. You know, again, you have to assume these things again to dismiss the practical, that shows that there is an upwards force. Again, if you understand the Earth is a creation, then then it's all working together. It's all created to work together. It's all a system, that works together. So again, to try and dismiss these practical demonstrations by assuming that, oh, well, how is it all moving up together? That again, you have to assume that they're built separately and they're independent from each other. And so again, it just doesn't make any sense. It's just a cop out in my opinion.
There's no will. You can do these very simple tests and see yourself. Look, it's very simple, Will. If I accelerate a vessel, this is a simple accelerometer as a vessel with air and water in it, okay? So any direction you accelerate that in, you will see the direction the force is acting in, because the air will move towards the direction that you're going in. Every single time, Will. Now, when you set a glass on the table and you watch an air bubble rising through that glass, it's showing you what direction the force is acting. It's very simple.
Yeah, I'm processing it. By the way, I think a lot of people, I'm noticing a little bit of a common theme in the flat Earth side with like 2 or 3 people, is this idea of not having a model. But I think you guys have more of a model than you would put forth. For example, you just said that the moon and the sun and the stars are also accelerating up, but that's not that's a model, right?
Yeah, but the problem is, Will, you have to be realistic. I'm 47 years old. I was born into this culture, right? And only in the last 15 years did I start to question these things. Now, these people have had generations to formulate a model. How do you expect me to formulate a model in the space of a decade with just me, with no resources? I mean, it's preposterous, Will. I have to, just like I question any other assumption I had in my life, I question the things that were put to me. It's not my burden to replace those things if I can falsify them. Falsification doesn't mean that I have to replace it with something else. But I can show you like simple aspects. Like, again, the significance of this is massive, Will. Globe Earth concept requires a physical downwards acceleration. It requires a force acting downwards. It does not get off the drawing table without it. Now, if I now give you the capabilities to go into reality and test that for yourself, you're going to find the exact same thing as I found, Will. How are you going to react then?
Well, here's what I want you to consider. I think something that I've done, which is minor, by the way, I'm not bragging, but I think something that I've done is going over people's heads, which is I have created an experiment that both sides not only have agreed to, but that both sides want to participate in together. And so in your example, with the accelerometer and all the stuff you're talking about, I would challenge you to see if you can figure out if you could do this with a globe earther and get the globe side to agree ahead of time with what the results would mean.
Right.
That is how we make progress in this debate, in my opinion.
But
the problem with that is that globe earthers already have their mindset. So when the observations or the demonstrations don't fit their model, their globe earth model, what they'll do is they'll come up with explanations to try and explain what's actually happening in freefall. Because again, acceleration in freefall defies all the laws of motion and acceleration. They'll come up with an explanation that, only in freefall is when gravity is able to accelerate all the matter together, and that's why it doesn't displace. So it's a magical acceleration that happens only in freefall, right? Again, you're special pleading for this force because every other example that can be demonstrated here on Earth will show that matter will always displace. Again, that's what an accelerometer is and what it does. It detects acceleration by displacing the matter that's within it, So again, whether it's a digital accelerometer, the components within it, the matter within it, displaces relative to the direction of the force, you know. So it detects the force and it also detects the direction of it relative to how the matter displaces. Again, that is what acceleration is. You know, it causes displacement 100% of the time. So the globe Earth explanation is that, in free fall, again, there's a magical force that can accelerate without displacement. But again, that defies physics. That kind of force cannot be recreated or demonstrated in any other vector. So again, it cannot be put through the scientific method. It's just an assumption based on the optical interpretation of objects accelerating down, again, which is faulty. You know, accelerometers easily debunk that claim.
But yeah, and again, well, I have to highlight the absurdity. It's like, if the Premier League, which has 20 teams in it in England, if 2 of those teams decide something, does that then mean that the other 18 teams are lumped in with those 2?
No, but it's a start.
It's not a start, Will. It's just gibberish. It's nonsense. So again, like, look, go and see if you can get a globe earther to come and have the discussion with me, because I'm telling you right now, not a single one of them has dared to come near me for that discussion. Not even one of them has made a response video to it, because it's physics, Will. They cannot escape it. All the globe earth has is special pleading for a special type of force that nobody can isolate, that nobody has access to, that nobody can recreate in any way, shape or form. It's a fantasy that they want me to accept. You don't trump physics by utilising mathematical concepts. Well, it's ridiculous. I operate in the physical. Look, you and I operate in the physical real world. We don't operate on a mathematics drawing board.
Yeah, I would push back on you a little bit about the fact that you're saying the globe side can't recreate it. There's like 1,000 things in the world we can't recreate, but that doesn't make them not real.
No, I know. But if you're making a claim about it, then you must be able to demonstrate it well.
Even life itself, we cannot create in a lab.
Exactly.
The most foundational thing in
Yes.
the full world.
Well, you're talking to the choir, mate. Exactly. So anybody that claims they know what life is, well, recreate life for me then. That's my attitude. So you're utilising things, well, that I've already covered, mate. Look, I'm not making assertions about life or consciousness or God or any of these, things that we struggle with. I'm talking about real world physics, well. Stuff that you and I have access to, that every other person alive has access to. That's the commonality here.
For example, what causes weight? What creates weight? What creates buoyancy? What creates orientation? What creates pressure gradients? What creates a vector, for example, right? All of these things that we experience here on Earth, can be recreated. It can be put through the scientific method and shown that it's a motion of a container that creates all of these effects that we're experiencing here on Earth. So again, Earth being the container that we live in, is showing us that there's a force upward. Again, we can recreate all of these effects utilizing one force, the density and buoyancy motion vector. Again, the density gradient, all of these effects, the pressure gradients, all of these effects can be recreated, again, utilizing one force, that being the motion of the container, again.
Again, I think it'd be great if someone on the globe side would do an experiment with you and agree, because if there's disagreement, then instead of doing the experiment, we have to figure out why there's a disagreement. So I picked something for the final experiment that already had agreement by some of the biggest people on each side.
But again, I'm just wanting to make that clear for anybody that watches this. These people that you're talking about do not represent me in any way, shape or form. I have never agreed to any of that. So to me, you can observe whatever you want about the luminaries. It's not going to change anything.
Mm-hmm. I should ask you a question. I have a scoreboard on my website of globe earthers and flat earthers. Do you want me to put you on the flat earth scoreboard?
Nope.
Okay.
There's no flat, Will.
Okay. Well, you're not going to. It's going to be hard for you to disagree with that.
Well, I've been saying it since day. This is why I'm saying, why am I on a list with flat earthers when I've explicitly told people over the years the Earth's not flat.
This is awesome. Like, I've been interacting with so many people all over the world. Obviously, you're in Scotland, and it's fun because I get to know people better. Like I had a very limited amount of time to watch videos, and I will admit I didn't watch as many of your videos as I did certain others, like, you know, Flat Earth Dave. But now that we're connecting, I'm understanding your position better. You've given me a lot to think about, and I'll definitely think about it.
Yeah, good. You know,
So again, I named the title of the video the final embarrassment because again, when we're looking at physics, you know, physics shows, you know, that the globe Earth is impossible by the fact that there is no physical downwards acceleration. Again, that simple fact debunks the whole globe Earth again because they require that to explain their whole model, right? So when you have grown men from the globe Earth side and grown men from the flat Earth side to go to Antarctica to try and prove the shape of the Earth, you know, that's embarrassing to have grown ass man thinking that they're going to prove, you know, the shape of the Earth by looking at the sun. You know, it's pathetic at the end of the day. It's embarrassing, you know, if you ask me, you know. So yeah.
you know, I operate in the physical world, well, just so that you know. So I've went through the globe Earth, I went through the flat Earth, and both are just as ridiculous as each other. Because this is why they debate each other, well, because both are concepts. They're not related to the real world. Physics is not up for debate.
I just thought of one other question for you, because this whole idea of whether gravity is real or we're moving up is an interesting one to me. That it's going to take tons of time to research to fully understand both sides. But I do have a question for you, which is this: considering that we see movement of the lights in the sky.
Yep.
What's your position on that? Are we moving or are they moving?
This is kind of relativity. I mean, for a fact, we are moving linearly. So to me, the whole system moves linearly in unison. But just like any other machine, you can have linear moving parts and rotational parts. So, you know, just because we see rotational components, you know, doesn't discount linear motion either. And because we see linear motion does not discount rotational motion. You know, any machine operates on those principles, that being leverage, and it can be linear or it can be rotational. So, you know, that's the way my mind looks at things and analyzes things as a machine. Because
just another thing to note, in my opinion. So when it comes to, again, the stars appearing to rotate, again, because that's obviously what we observe, that doesn't mean that whatever it's containing the Earth, the atmosphere, you know, people like to call it a dome, whatever the hell people want to imagine, just because we see that stars appear to rotate, that doesn't mean that the container is rotating as well. Just want people to think about that, because a lot of people I would assume that because they see the stars rotate, they automatically assume that the container, you know, is also rotating, which is giving that illusion. So again, the lights could be rotating again, but that could be completely separate from the actual physical container. So the lights could be rotating, but that doesn't mean that the container or the containment of, you know, that's keeping the atmosphere in is also rotating. You know, just wanted to make that point. So again, the stars could be rotating without the physical container actually rotating as well. That, you know, at the end of the day, nobody knows. You know,
reality for me functions like that. It's very machine-like. You know, that these principles cannot be broken. So, you know, I see the whole thing. I don't think there's a separation of us in these things. Obviously, there's distance between us, but just like there's distance between you and the internal combustion engine in your car, doesn't mean there's a separation between the car and the internal combustion engine.
Yeah, but since we see the stars moving, is your position maybe the stars are here, and as the Earth is going up, the Earth is spinning maybe?
Well, no, I don't think that. There's a possibility. Well, I'm not going to rule any of that out, but, you know, I'm not that far down the road yet.
Okay, so in your model, it is possible that the Earth is rotating?
There's a rotational aspect to it, definitely. Yeah.
Okay, well, hey, there's some potential common ground. I love it. It's great.
Exactly.
Again, there is a rotation that we see again, but we don't know exactly what's rotating. Again, it could just be the lights that we call the stars. It could be the dome or the container. You know, people the Earth, I guess, but again, at the end of the day, looking at the stars, and making, assumptions about it, again, it's a completely different subject when it comes to establishing what the Earth is.
It'd be just like your demonstrations of motion with the rulers when you can't tell what's
Exactly.
moving
Yeah.
on the inside.
Exactly, relative motion, again, we see an apparent motion, again, but we don't know exactly what's going on.
There's just some main points of contention with me, in the globe Earth. I mean, the globe Earth is no actual real world physics. It's mathematical and it's observation based, making assumptions about, intangible phenomena that you view optically. It's not physics. And they make certain assumptions of these things and construct a conceptual model, which is fine. But the globe Earth are not honest in that regard. They don't admit that their model's conceptual and based in mathematics. There's a difference. As I say, I can take what I'm talking about and demonstrate it in physics, actual real world tangibility. And you can recreate it, and then everybody else in the world can recreate it right now. To me, that's the definition of true science. But I don't know if you've not seen any of my street interviews. Well, there's a massive problem because I interview like university students, and it became very apparent to me that these people do not have a clue why they believe what they believe. They don't even have a starting point to justify the beliefs that they hold, which I think is astounding.
Yeah, the majority of people that believe the globe Earth don't understand why they believe it, and the people that do think they understand the globe Earth simply have a false premise. Again, the biggest one being that they believe that there is a physical downwards acceleration, aka gravity, being a pulling force. So a lot of the people that think they understand the globe Earth model, again, have a faulty understanding of what gravity actually is. Because again, even mainstream admits that gravity is just a theory, because they admit that, again, the downwards acceleration of force in freefall has never been measured. And they have to concede to that because that's the reality. If they were to make a claim that it does detect it, the practicality will show automatically that they're bullshit. So they have to concede that fact that there is no acceleration in freefall, there is no force in freefall. But this is where the explanations come in, right? This is where Einstein comes in with his bending and warping of space-time explanation. Is literally there to warp people's minds. I think it's in the name for a reason. The bending and warping of your mind. That's what the bending and warping of space-time is. It's literally the bending and warping of people's minds to accept something that as ridiculous as objects accelerating down without a cause, without a force. Even though they'll admit, in the first law of motion, that an object at rest will remain at rest unless there's a force acting on it. Again, this is a law. This is reality. That's a fact. But then they go and say that, gravity can accelerate objects without a force. An object can go from being at rest to accelerating without a force, which is a direct contradiction of the first law of motion. Again, a theory being a direct contradiction of the first law, because again, they require people to believe in this nonsense of pulling forces of gravity.
Yeah, I agree with you on that. And I would say that that's probably a common theme among everyone, not just people who believe we live on a globe.
Of course. There's so many things that people assume and believe in their life that they've never addressed. And when you question them on it, it becomes very apparent very quickly that they don't have a clue, which I think's, really telling and really significant.
Yeah, it is. But by the way, since I can't see the chat, has anybody had any questions for me?
Oh, I've not even seen it either, mate. I'm just on here with YouTube. 2 seconds, I'll look.
I still have about 5 more minutes. I just want to make sure if anybody has questions, we get those answered.
Well, we'll maybe take the Awake Soul standard and start asking you about your underpants and what's your favourite nipple grip and what do you get up to in your sex life? Well, what's your favourite position, mate? This is the stuff that we really need to know.
I did appreciate your email, and that interview was great.
This is why I've been saying for years that I want to distance myself as much as possible from these people, because they're irrational and they don't even have manners. They don't even have basic manners, But anyhow,
Yeah, agreed.
let me see here. Right, anybody, any questions in the chat? Well, my attention's on it. I'm just going to flick back to me just now so that people don't get confused. Yes, you heard right, nipple grip. I wanted to know what Will's favourite nipple grip device was, because that seems to be relevant amongst flirts, apparently. Any questions? If somebody's asking, are you related to Simon Dan?
I am not related, at least not that I know of. So.
I'd have to stick up for long and say he's a bit better looking, to be honest with you.
So it sounds like there's not a lot of questions?
People here, but well, you have to know the audience here, mate. The people here know me and they know the position. So, everything I've said in regards to the observations, we've got, Andrew's saying, asking a question, how does the globe Earth model work when the ground moving upwards would explode it?
That doesn't sound like a question for me.
Well, if we can demonstrate to you that the force, you know what force is? Well, do you know what a force is? Sorry, I don't want to be condescending. Just
I remember I remember being taught the definition of force, but I forget exactly what it is.
Well, there's a mathematical description of force, which is F equals ma, blah blah blah. But a force basically is just something external to matter, acts upon matter, and puts it in motion. Would you agree with that?
Say that again.
A force is if you've got inanimate matter, right? A force is something that's external to matter and acts upon it to make it move. So, if you're in your car and you bump into another car that's stationary, you're the force, the matter that's in motion that apply pressure to that other car and put that in motion. So force is just matter in motion.
Okay.
Right. So Andrew's asking that question. Force, if you understand force being motion, then we're asking, if we show you that the motion of the Earth is linear upwards relative to us towards our feet, how does that work on a globe Earth? How could it work on a globe Earth?
I'm open to seeing that, but this is kind of the first I'm being presented with this idea that the Earth is moving upward.
Well, the question's simple. If you've got a globe and it was to move outwards in every direction, what would happen to that?
It would either get bigger or it would come apart.
Yes, that's what he was asking. That's it. Simple.
Okay,
that.
got it.
That's it. Let me just check, see if we've got any other underpant questions. What is his position? He has globes and flat map and his what?
Okay, so I know exactly what he's talking about. So the final experiment, I created this to be a fair, unbiased experiment that has both sides participate. So I've got both models here.
Mm-hmm.
I've got both models behind me of the Earth, and then I've got both models of Antarctica as well.
Yeah.
We're trying to figure out if Antarctica is an island or if it's an ice wall holding in all of the water on the Earth.
Mm. Yep. So, I mean, at the very least, to me, in my mind, all this would do in regards to these morons who like to debate, it would just be a point scored for one or the other. It would just simply be that for me. There would be no other relevance to that other than just a point being scored, because of other people who deny the globe have shown the flaws with these circle maps for a number of years and highlighted absurdities with these circle maps. This is flat earthers I'm talking about. And they've been fighting against these mainstream kind of flat earthers for a long time. This is why I think, to say it's a false dichotomy, what you're presenting, Will. I think but I'm not saying you're dishonest. I don't mean that. I think it's just because you don't have a full grasp on the complexity and the dynamics, the amount of different people who are involved in this, who come from different perspectives. You've isolated these, what you call main characters, Jeranism, Dave Weiss, these types of peoples. And I think it's disingenuous to then generalise across the full board, because there's people who have been actively highlighting flaws with both of these models for a good number of years. And a lot of people feel maybe a bit triggered and a bit attacked by that. Well, I'm just informing you so that you may get a better grasp on where people are coming from and why they're a bit defensive. You know?
Yeah, no, I do appreciate it. I'm learning a lot, and there's definitely more diversity on the flat Earth side, and so I appreciate this. Thank you.
Yeah, no worries. As I say, I hope that you, I don't know what it is you think you're going to achieve, but it's not going to settle anything. It's going to create more debates between these two factions who push these two models. That's the only thing that's going to happen. As I say, if you want to talk about the surface of the Earth, a direct measure would be a structure built over a standing body of water, and that would give you everybody a physical measure. You what direction the force is
Oh
acting.
my God.
It's very simple.
Oh my God.
An ice wall holding in all of the water on the Earth.
What was that from?
To say it's a false dichotomy what you're presenting, well, why these types of peoples.
Sorry about
And
that.
I think it's disingenuous to then generalise across the full board, because there's people who have been actively highlighting flaws with both of these models for a good number of years. And a lot of people feel maybe a bit triggered and a bit attacked by that. Well, I'm just informing you so that you may get a better grasp on where people are coming from and why they're a bit defensive. You know?
Yeah, no, I do appreciate it. I'm learning a lot, and there's definitely more diversity on the flat Earth side, and so I appreciate this. Thank you.
Yeah, no worries. As I say, I hope that you, I don't know what it is you think you're going to achieve, but it's not going to settle anything. It's going to create more debates between these two factions who push these two models. That's the only thing that's going to happen. As I say, if you want to talk about the surface of the Earth, a direct measure would be a structure built over a standing body of water, and that would give you everybody a physical measure.
Let's do it.
Yes, well, apparently you're a millionaire. Are you? Are you a millionaire?
There's all kinds of rumors going on.
That was me being awake, so I was there. My next question.
Here's what I will admit, okay? I hate to admit this, but you guys are all pressuring me. I have less money than Elon Musk, okay?
Well, my next question after that, was going to be, can I get a tap? Do you know what that means?
Tell me.
That's Scottish for going to give me some money. Can I borrow some money off you, Will?
I love it. Well, hey, this was great. I got to run.
No worries.
If anybody wants to follow what we're doing, it's just the final experiment on YouTube, and I will take into consideration all these new nuances I'm learning, and if I can come up with something that might excite you, I'll let you know.
No worries, mate. If you want to know more about the motion aspect, then I've got a plethora of physical tests that you can recreate for yourself. And
Okay.
and if you're honest, then you'll look at these tests, you'll recreate them, and you're going to be left with no other conclusion than the same one that we've arrived at. So, if that interests you, give me a shout. Well,
I will. Thank you so much.
no worries, mate.
Bye-bye.
Take care.
All right, so that was a conversation with Dell. Obviously, I think Dell did a great job, presenting the facts, I guess, and obviously shows that Will Duffy was just either completely uninformed or obviously added. Again, we don't know his intent at the end of the day. Point being is that obviously his final experiment is a false dichotomy because, again, looking at the sun is a completely different subject, when it comes to the shape of the Earth. It's not going to prove anything. Again, you're going to have to assume a model and assume what the sun's actually doing to be able to even take any of that serious. But again, at the end of the day, it doesn't prove anything. Again, it's embarrassing that grown men, if any, are taking this serious, and thinking they're going to prove, anything with it. So yeah, it's pathetic. So there is another short clip that Will Duffy had with on Natch's channel, and where he basically not volunteers, but basically says that he'll fund the final the force the line, not the force the line experiment, which is the physical measurement. So in my opinion, I think he's bluffing, which is why I titled the video "Will Bluffy." So until he builds, this structure, in my opinion, he doesn't deserve anything but to be, called, call it a bluff. Until this actually gets done, if he's actually a millionaire, and if he's actually honest and he actually wants to put this whole thing to bed, then in my opinion, it's just, why not do it? A direct physical measurement, right? So unless it's a bluff, right? So.
And just to add, I think it's a little humorous that, the stationary Earthers or Glovers have so many requirements and have so many questions and so many things that, a rising Earth have to prove, but yet they'll settle for an observation.
Yeah.
To prove their,
Yeah, I mean, always, yeah, exactly. The observation of object appearing to go down, for example, that's enough for them to accept.
Or the sun observation.
Or the sun observation, either or, like, it just doesn't make any friggin' sense, But yeah. All right, play a little bit of this. Should give me a share screen. And again, if we have some time, I'll open up the panel, and we'll see if anybody wants to join.
I think I'm not going to consider it a cop-out, but I am at least going to ask you for a favor since you are taking this position.
Yeah, go ahead.
My favor is very simple. What is something that you think is impossible that, if done, would falsify?
In a position at the moment to be able to talk about that. So I do
okay.
apologize.
Oh my God. Where did I have it? Okay, it wasn't there. Did I go back?
Flat Earth. So, like, if it happened, it would falsify flat Earth.
Okay.
I haven't thought about this actually. So, I mean, like, I guess finding curvature, right? I mean, that would be
okay. Perfect. Perfect.
Yeah.
So you think there's no curvature? Great. What could someone show you that would convince you there's curvature?
I mean, curvature.
So again, in this one, what could someone show you to show you that there's curvature? Well, simple. See. Again, a physical measurement like this. So this is what will be acceptable, again, to show that there's curvature. Again, a physical measurement, of Earth, of water, water level, again, because they're claiming that water level means curve. So again, a direct physical measurement.
Like you mean like a photo or data that should,
What would convince you, what, there is curvature, I was wrong?
Well, I guess from like the way I would look at it, like water is level. So vast bodies of water, right, that's been measured to be level. And if it's not level, then I guess there's something of a mistake that I understood about how water works, right? Because water is something that I could take a look at and say, well, over 10 miles, 100 miles, etc., there should be a certain amount of curvature for that. No?
Yeah. So what could they show you that you're like, you know what, you're right, the oceans do have curvature. What would you accept?
What would I accept? Like, other than a photo that we can see too far?
Would you accept a photo?
Yes, I guess so. I mean, like the photo that NASA gave.
Obviously, Natch already kind of went over this and obviously admitted that obviously a photo is not good enough. So I just wanted to highlight that, obviously, that, a photo of anything, about the physical world is not proof of that, because if I showed you a picture of me flying, that wouldn't prove that I could fly, right? Even if I showed you a video, anything that defies physics and a claim that defies physics, or any claim that, for that matter, about the physical world, again, if it's just an image or a picture, it should not be taken serious. We need a real world, a practical demonstration that can be recreated, again, that can be put through the scientific method of observable, measurable, testable, and repeatable. Again, that's how we prove things to each other.
Not just observable, which is what this whole experiment is getting stuck on.
Yeah, just
one aspect.
Yes, just the observable. Again, what about the measurable, testable, and repeatable? Again, that requires physicality. That requires, you be able to manipulate, the variables and yeah.
So gave me, or somebody else, a laser experiment would also be pretty good, right?
Well,
how about a rail gun? How about a rail gun shooting another ship at 100 miles away?
How about, here's the problem. The stuff you're telling me is the opposite of what I'm asking.
Okay, so like what is it possible for you and I to do?
Because of all of those things, the globe Earth has explanations for. And again, he's asking for something that could be concrete, right? Something that will prove or disprove the flat Earth. In other words, something that wouldn't work. Again, it will be a direct measurement of curvature. That wouldn't work from a level Earth or a flat Earth, right? So.
To be able to do.
No, not necessarily. Just what could be given to you that would convince you that the oceans do have curvature? That's it. That's all I'm asking.
Show me curvature. Show it to me. Show it to me.
Okay, so but again, how could someone show you there's curvature in the ocean? What would you accept?
I guess I don't know, like a photo, or tell me that this is a certain distance away, and then this is the amount of curvature that we have measured. This is the curvature that we have measured, and this is all the data that is involving that curvature. So that would be something that I'll be willing to take a look at. And if I trusted that information, then I'd be like, oh, I guess there is something here.
Okay, I got a simple one. Tell me if you'd accept this.
Okay.
A lake that has a dock on each side.
Okay.
And so the globe would say there's curvature. So one dock is here, one dock is here. And so we think if one person stands on one dock and one person stands on the other, they won't be able to see each other using any type of zoom. Would that convince you?
Yeah, I guess so. I mean, like,
again, that is just relying on vision alone. Again, so if you don't take account of perspective, because again, at the end of the day, as human beings, we don't have infinite vision. So there is a limit to how far we can see. So if you hold an object in front of you and you move it away from you, it's going to disappear, from your perspective. Because again, we don't have infinite vision. Not only that, the horizon, again, people think it's the curvature of the Earth, but in actuality, the horizon, it's not a real physical thing. It's actually based on perspective. It's simply the limit of perspective. It's how far we can see. So again, if somebody is seeing the horizon 6 miles away, but somebody is 10 feet above them, their horizon is going to be further out, So again, horizons are relative, and again, they have to do with perspective. They're not a physical thing. So again, if you're making observations, long distance observations, and you don't take account of perspective, and you're claiming, oh, that's the curvature of the Earth obstructing my view, and you don't take account of perspective, again, that just shows that you have faulty reasoning. You're starting from a false premise, and you're making these observations fit your model, which again, is not proof of anything at the end of the day. Simply observing something doesn't prove anything about the physical world.
If you tell me the measurements and how far the docks are away, and according to a curvature model, right? According to the curvature model, they would be like looking past each other, right?
I'm saying there'd be so much curvature on the globe model with the lake that you would not be able to see the dock or the person standing on it.
Yeah, they should be covered behind a ball of water.
Yes. Okay, cool.
Agreed.
Do you think you could get any other flat earthers to agree with you? Because if there's enough, I might fund it.
I can try. I can definitely. I mean, I have a flat Earth channel, and then we can be in contact and then we can try to get some people together. But they've already done this behind the curve. I don't know if you've seen the Netflix behind the curve.
They said there was. They say there's like editing and stuff. So I think we should just redo it where we get all of us together. It'll be cheaper than going to Antarctica. We pick a lake.
It will be.
We pick a lake, and if you can get flat earthers to agree with you, I will fund this. I'll fund for everybody to come.
So that's the thing. I think the thing to do is for me to communicate with people and think about a good quote unquote experiment regarding a lake, and the distances and all this kind of stuff, and then we can be in contact with each other and see what happens after that, right?
I'll email it to you.
Email me what?
I'll email you information. Yeah.
Okay. Yeah. So
okay, let's force the line.
Yeah, force the line. Yeah. What about that? You were saying something about that.
Okay, so I have the same offer out to people. I will fund Force the Line if we can get enough flat earthers to agree that it would falsify flat Earth.
So I'm glad Will Bluffy, because for a second I thought did we skip where they talk about Force the Line? Because all of this, they were talking about the observing, one person on one dock at the end of the lake, observing the other person at the end of the lake. So that's what he was willing to fund, but I'm glad he brought in the Force the Line and saying that he will fund that as well. So again, the observation one, just observing someone from one dock to the other dock, that one's not going to prove anything. Again, the Force the Line experiment, the physical measurement, the direct physical measurement of the Earth, that is what's going to show the curvature or the lack thereof, right? So again, the fact that he's trying to say that, I'll fund it, but you have to get 50 flat earthers to agree. Again, this is, to me, is completely irrelevant. Like for him to even go this route. Again, if you're truly honest, if you truly have the money, again, at the end of the day, and you want to put this whole thing to bed, just do it. Unless you're bluffing, Again, at the end of the day, I'd say, from now on, we should, everybody in the community, right? Anybody that's in this should call him Will Bluffy from now on until he does this experiment of the Force the Line, which has been the experiment since 2015 that people have been talking about. 2015, 2016, that experiment has been talking. And look, now we're 2024, and barely somebody's willing to actually fund it. So I say call them out on it, call the bluff. And again, that's the only experiment so far, that could be taken, serious. But, at the end of the day, we know that the physics of water, again, water doesn't have the ability to do that. So, and not only that, the fact that the whole globe Earth model requires that there's a physical downwards acceleration of gravity, which doesn't exist. We know that the whole globe Earth model is bullshit at the end of the day. So again, if any experiments are going to be done, at least a physical measurement of the Earth, at least that should be put forward, So.
But again, still leaves out the measurement, a physical measurement of downwards acceleration.
Yeah,
at the same time.
Exactly.
It's not just proving the curve.
Okay, so like if you do the Force the Line and then it actually falsified the flat Earth, then and if they agreed that it would falsify the flat Earth, then you would fund it, correct?
Yes. So here's what I mean. I mean, if they would agree ahead of time publicly, I had one guy say that he could get 100 flat earthers to publicly state this, and he hasn't given me one yet.
Okay.
If we can get like 50 flat earthers to say that Force the Line would either prove the globe and falsify flat Earth, or prove flat Earth and falsify the globe, and they say that publicly, I'll fund it.
Okay. So so like you know what the Force the Line is. It's like there's level, there's plumb, and everything is 90-degree angle. So it's just all a long structure of 90-degree angle going out. So on a curved surface, basically your structure will be going over and will get taller and taller and taller and angled because you're on a curvature. But on a flat surface, basically it will be maintaining its levelness or evenness parallel with the surface on top, right?
Yeah, I'm very familiar with it. Now, people tell me that it's cheap. I don't think it's going to be cheap.
No, it's not cheap.
But if we can get, again, I learned from TFE that if we don't get both sides to agree ahead of time, it's not going to be worth my time and money.
Well, that's the thing. Yeah, I mean, like I would have to.
I mean, it's kind of weird because, I mean, everybody, you know, a lot of people have been saying that obviously that the TFE, you know, it's obviously bullshit and all that. So for him to say that he wants an experiment that both sides agree on, I mean, everybody disagrees with this one, but yet he's still going through with it. You know, so again, it's kind of going back on his own logic there, saying that, oh, if people don't agree with this, then it's going to be a waste of time. Like, well, people don't agree with the TFE as it is, you know, observing the sun. So again, you're wasting your time, you're wasting your money, like you said. So again, a physical measurement, again, is what people have been asking for, and you know, it's going to be a real experiment because again, it's a direct physical measurement again that anybody can verify. I guess, you know, it should be verifiable, you know. So
have to agree that both sides would have to come to an agreement about what would be acceptable. And me as a flat earther, like I mentioned before, me as a flat earther, I look at the TFE as a kind of a false dichotomy, because in my mind, just whatever you observe up in the sky doesn't change the convexity of the ground that you are on. That's me. Okay, so you are not going to be able to convince me. Other flat earthers who are already on that camp of, because they see the 24-hour sun, Earth cannot possibly be flat, and they also believe that we are on a giant Home Depot or something like this. I do not agree with them, and they don't represent me at all.
Okay, I understand that. I will tell you that I have a video I'm working on, which I haven't told anybody anything about, but I will tell you what it's about. It's the most important video I've done. I think I can prove that there are only two possible models in the world that we live in, and that's the globe and the AE map. And I'm going to tell you how I'm going to prove it, and I don't think you're going to be able to.
So this is Will just trying to pigeonhole people into the AE map in a way, how it can only be the AE map versus the globe. And again, that's how they're kind of setting this up, in my opinion, to push this the final experiment, you know, the 24-hour sun in Antarctica. That's just how they're making it relevant. Is by pushing two models, which again, it's making assumptions about the dimensions of the Earth and the layout of the continents. Not only that, making assumptions about the sun and what it is and what it actually does and what we're actually seeing. Again, making assumptions left, right, and center again, but it seems like it's a setup again to try and attack the Gleason model of the flat Earth, which obviously there's a lot of flaws with it that a lot of people have pointed it out, you know, in the past, you know, and are still doing so, but yet they're still trying to push it as that's the model that flat earthers have to go by, you know, because again, they can debunk that model, and again, they can give the impression, you know, that they're proving the globe by debunking the flat earth model again. But again, reality is not a model. Physics is what it is. It's not up for debate. You know, and physics is what shows that there is no measurable curvature, again, water being level when contained at rest, and also the fact that there's no displacement in free fall, and there's no detection of any accelerometer for that matter, whether digital or an analog, that can detect this magical acceleration in free fall. You know, so
able to respond right away, which is fine. Think about it, and then maybe let me know if you can refute it in an email, but I don't think you're going to be able to. We have 100,000 commercial flights daily. We have 100,000 commercial flights every single day. Those flights start where they're supposed to start. They end where they're supposed to end. They get there in the right amount of time. We have so much data, it's overwhelming. That data can only work on a globe or an AE map. That's it. There is no third model that all of that flight data works on. And so I'm gonna push, when I release my video, that everyone either accepts the globe model or the AE model and pushes back on people when they claim that there's a third model.
okay, so yeah, that's pretty much it. Again, trying to pigeonhole people into the AE model based on flight paths again. Airplanes, again, they literally just use GPS. They fly over a projection. Pilots don't really use like real tools like they used to use back in the day. You know, they literally just use GPS and follow the coordinates that they're given. You know, and yeah, technically, most pilots don't even know what the hell they're flying over. You know, they're just following the GPS and that's it. So again, to try and push this data and you know, as fact of the dimensions and the layout of the Earth, to me, is obviously, again, it's faulty reasoning. And again, they're just trying to pigeonhole people into these maps and these models because they can easily, you know, attack them and they can easily debunk them, giving the impression again that they're debunking, you know, the level Earth. But again, at the end of the day, you can debunk physics. That's what it comes down to, you know. And physics is what proves that the Earth is not a globe, and again, that it will be impossible. So, let me go ahead and stop sharing the screen. All right, so I guess what time is it? All right, so I'll open up the chat. Again, mainly for people that want to have a conversation about the topic at hand. Again, the shape of the Earth. Again, if you disagree with the motion of the Earth, I would love to hear your reasoning why. You know, also if you believe in the globe Earth, I would love to, you know, to hear your reasoning why. You know, again, motionless flat Earth as well. Any beliefs you have about the Earth, I would love to hear why. You know, so if anybody wants to join, I'm gonna post the link for a bit. Let me see. Yeah. There's the link. I'm gonna try to pin it. Let me see. Oh my God. I don't know why that happened. I have to close that. Close this. Give me 1 second. Okay. So there, I posted the link for anybody that wants to join. And again, you want to share why you disagree with the motion of the Earth, or you want to share why you believe the Earth is motionless, or the Earth is a globe, or if you think there's a more important topic than this. Because in my opinion, again, people talk about, there's more important topics to talk about. But in my opinion, obviously, if you don't have common sense and you're trying to talk about any other subject, in my opinion, it's like you're trying to run before learning how to walk. So again, if you believe the Earth is a ball or something that it's not, and you're trying to jump into another topic, then again, you're trying to run before learning how to walk. So again, if you believe in the globe Earth, then you have no common sense, which means you don't have the tools necessary to jump into any other debate or any other discussion about this place, you know, in my opinion. So that's where the shape of the Earth does become important, because again, it has to do with common sense, which is a necessity if you want to, you know, talk about, you know, other subjects, you know, for example, politics and all the other stuff, you know. But
again, I'm gonna moderate the conversations. Again, if anyone's speaking over anybody, I'm just gonna go ahead and mute as I see fit.
Yeah, I guess we'll give Brenda a chance for a few minutes. And to be honest, I'm not even looking forward to this conversation, but sure, you can add them. Hey, Brenda, can you hear me?
Yes, I can hear you.
Okay, cool.
How's it going?
So it's going good, going good. So I guess we can start with some, you know, establishing some basic principles. So can I ask you, for example, the first law of motion, an object at rest will remain at rest unless there's a force acting on it. Do you agree or disagree with that law?
Sure.
You agree with that law that an object at rest will remain at rest unless there's a force acting on it? Right? You agree?
Yeah.
Okay. So you claimed in the comments earlier that gravity is not a force. So how can
It is not.
an object? Okay. So how can an object being at rest and when I release it, how is it that I'm not? Because again, the first law states that a force is required to put it into motion. So how is it that gravity, not being a force, put it into motion?
An object in general relativity, an object in free fall is not accelerating.
So the change of rate that we witness, what is that change of rate? Isn't that acceleration in your model?
From our frame of reference, not from the object's frame of reference.
But if you're claiming that the object is moving towards the ground and there is an increase in speed, not only from being at rest to moving, but also per second, that is the literal definition of acceleration, isn't it?
From our frame of reference, not from the object's frame of reference.
So what's happening from the object's frame of reference?
It's not moving.
So the Earth is not moving towards the object and the object's not moving towards the Earth is what you're claiming?
No. From its frame of reference, it's not really moving. The Earth is moving towards it. Right? From our frame of reference, it's falling and accelerating.
So you're claiming the Earth moves towards it?
From its frame of reference.
So from the object's frame of reference in free fall, the Earth moves up towards it?
Yes.
And then from our frame of reference on Earth, the object moves on towards it. Is that what you're saying?
Yes.
So they're moving towards each other, is what you're saying? Both the free falling object and the Earth are both moving and meeting each other?
The difficulty that you're having is that there's no absolute frame of reference. Everything is relative. Motion is relative to your frame of reference. There's no absolute reference frame for motion.
Let me ask you this. Does acceleration, a physical acceleration, does it cause displacement? Yes or no?
I don't know what you mean by that.
So if
Displacement of what?
If I have an accelerometer, for example, on my phone, and I physically accelerate it in any direction, up, down, left, or right, will that accelerometer detect that acceleration?
If you accelerate your phone, the accelerometer, which will do what it's designed to do and detect the acceleration. But right. Imagine an asteroid out in space. If it's accelerating, I don't know what you mean by displacement. It's a rock.
Yeah, but the accelerometer, the components that make the accelerometer, the internals, the displacement that occurs in the accelerometer, that's what detects the acceleration.
Displacement is the wrong word. You're thinking of inertia. There will be the way you can detect acceleration is by inertia. The way the MEMS device works is because it has a tiny little bar that bends and flexes when it's subjected to acceleration.
Exactly. The displacement is due to the inertia of the
and if you take a cell phone and you drop it while it's falling, it will register no acceleration.
Exactly, because the objects don't accelerate down in free fall.
Right. Like I said, under general relativity, objects in free fall do not experience acceleration, and you can prove that with a cell phone.
Exactly. So that means that proves that the visual interpretation that people have of object accelerating down in free fall, it's not real.
No, that's incorrect, because motion is relative. All reference frames are legitimate. It's legitimate to say it's accelerating from the outsider's reference frame, and it's legitimate to say it's not accelerating from its reference frame. No, it isn't. It's general relativity. There's no absolute reference frame.
Again, that's just word salad, because we have devices that can detect motion, that we can test and repeat.
You're right. And when you drop a phone, it doesn't detect acceleration.
Exactly, because there is no acceleration in free fall. It's literally that simple.
From our vantage point, from our reference frame outside of the phone, it is accelerating.
Okay, so let me ask you this. If you believe objects accelerate down without displacement, for example, an accelerometer can accelerate down, again, without displacement, let me ask you this. Why do you believe that's what's happening in free fall?
Displacement is the wrong word. It's inertia is the right word. That's the word you should. Displacement is.
Again, the displacement is due to inertia. So I'm just moving forward.
The reason that water and air displace inside of the bottles that people have been using is because of inertia.
Yes, the displacement happens due to inertia. I agree.
Yes, resistance to acceleration by mass.
Okay, my question to you is, why do you believe that kind of acceleration happens in free fall when we cannot recreate or demonstrate that acceleration?
It doesn't happen in free fall. It doesn't happen in free fall, and Dell proved it doesn't happen in free fall. When you drop a bottle filled with water, there's no displacement.
And you believe that gravity is the cause for that bottle coming towards the ground, right?
Gravity is, right,
the cause for
the objects in free fall. That's what gravity is.
Let me ask you, why do you believe that gravity is causing this acceleration down?
There's no acceleration when you drop
this movement from an object being at rest, that movement of the object going down. Why do you believe gravity is doing that?
It's from our reference frame outside of the water ball.
Okay, but why do you believe that?
Because that's what we see.
So just based on observations, what you're saying. That's what you believe.
Experimental observation, absolutely. General relativity is confirmed by experimental observations.
So again, making assumptions, observing something and making assumptions is not an experiment. So an experiment.
I didn't make an assumption.
You are making an assumption that it moved down towards the Earth.
That's not an assumption. That's the observation of the experiment.
Yeah, exactly. You're making an assumption based on your observation solely.
No, I'm not making an assumption. That's what we observe. The bottle of water moves relative to our reference frame.
Exactly. It appears to move.
No, it doesn't appear to. It doesn't appear to. It actually moves.
The object moves down towards the Earth, is what you're claiming.
From our reference frame, yes.
Yes, even though
you're still tripping over the, or you have to sort of like grasp the idea that you can have two different viewpoints, one reference frame and another reference frame, right? And they are both legitimate, right? From the bottle's reference frame, it's not moving. The Earth is moving up to it. From our reference frame outside of the bottle, it's falling to the ground. Both are legitimate.
Again, that's just word salad. You're claiming both.
That's literally general relativity. It's not word salad. It's been thoroughly described by physics. It's been physics for over 100 years.
Again, general relativity is just a theory. It's a mathematical.
No, it's not. It's a scientific theory. It's a scientific theory. Theories are confirmed by observations and experiments. Observations and experiments have confirmed relativity hundreds, thousands of times.
Again, observations alone, and again, you have to be making assumptions because, again, you're basing it based on observations. Again,
no, it's not based on assumption. It's based on the results of experiments.
Well, not experiments, observations. You call them experimental observations, but in reality, they're just observations.
Observations and experiments are both tests of a hypothesis, and that is how science is done. Science is you ask a question, you form a hypothesis, you deduce the consequences of the hypothesis, and then you conduct an observation or an experiment to test that hypothesis. If you get positive,
observable, measurable, testable, and repeatable.
Absolutely, you're
just
correct.
Unobservable.
Yes, it's obviously so. Observations are confirming evidence that support the conclusion of the hypothesis and enable us to form theories. The theories have explanatory power that explain the observations.
So again, like
Theories
your
are
own words.
facts. Theories are not facts. Theories
Exactly.
are explanations of sets of data, of experiments.
Exactly. Like you said, theories are not facts. So do you have any facts to share that your hypotheses are correct?
That would be the results of experiments. A fact is the result of an experiment. So the
And what
fact
experiment did
is,
you do to
the
prove
fact
your general relativity?
what Dell did is he dropped a bottle filled with water and he observed that there was no displacement. Therefore, there was no force acting on the water. It was not accelerating. That confirms general relativity, which says that an object in free fall is not accelerating.
Again, that only confirms the bias of the globe Earth believers. Again, because it's just,
No,
it's just a theory and it's an explanation.
It's not just a theory. Science isn't just a theory. And number two, general relativity could be true or false, whether or not the Earth is a globe. The geometry of the Earth is independent of whether or not relativity is true or not. It is not dependent, right? Right? The geometry of the Earth is that it's curved. That's an objective fact that we can observe and measure.
How did you physically measure the curvature of the Earth?
It's a drop. It's drop over distance.
How did you measure that? How did you physically measure that drop?
We can measure that in any of a number of ways, right? By conducting geodetic surveys, and you measure the spherical excess of triangles that are observed by geodetic surveyors, and this conforms with previous measurements of the Earth's size.
You're talking about observations of the stars?
No, I'm talking about the Earth.
Yeah, so how did they physically measure? How do surveyors physically measure the curvature?
They measure point to point, from point to point on the Earth, say from one point to another, and they construct triangles and then connect those triangles. Then they calculate the inner angles, and those angles will add up to be greater than 180 degrees, which shows that they are spherical triangles. And the amount that they're over can determine, right, the curvature of the ground that you're on, which in this case is the Earth. You could do geodetic surveying on Mars or on the moon. You would get different results that would conform, and show you the curvature of the moon or Mars.
Okay, so you basically don't have a direct physical measurement yourself.
Oh, this is a direct physical measurement. You take a tripod with a theodolite, which is basically a telescope, and you sight to another one, and you measure the angles. Those are physical measurements of angles, and the angles add up to be greater than 180 degrees, which is impossible on a flat Earth. Falsifying flat Earth and measuring the curvature.
You're measuring observations again.
Again, measuring angles.
We're talking about measurement of the physical ground.
How else would you measure an angle other than by observing it?
I'll tell you how you can measure the Earth directly is by building a level structure or a body of water and physically measuring for the deviation of water.
Yeah, but that's never going to happen because there's no material that won't sag over a distance of, say, a couple miles.
It can easily be created using posts to support it down the way to keep it from sagging. So that can easily be accounted for.
These posts will all be the same height?
The post doesn't matter how high they are. It's as long as the level, the structure remains perpendicular to the starting plumb. The post doesn't matter if they're in an angle, doesn't matter how tall they are. The posts are just going to be there for support.
Well, then why not just do a direct line of sight?
Because direct vision alone is not a direct physical measurement.
But how are you going to know that the posts are at the proper height without sighting from the origin, a perpendicular line, right? You have the origin, A the point A, right?
We're not measuring the post.
You have a zenith, and you measure 90 degrees, right? That's what you want, the 90 degrees line, and that's horizontal. It goes straight out. You're going to have to use an instrument, right, to sight along that line so that you know what height to make those posts.
Sure. The again, as long as we keep the structure, the materials we're using to measure this, parallel to each other down the way, then it can be easily be done.
So why use the structure at all if you're just using line of sight? Just use line of sight.
Line of sight is not a direct
because
there's
line of sight is how you're going to verify that the posts are the correct height. Right?
We're not measuring the post height. We're measuring the structure. The posts are just going to be there for the support.
Right. Then how will you know how high to build them?
Well, based on the structure itself, how we're building it, then we'll know how tall the posts need to be to maintain it at that level.
Exactly.
We have to maintain the structure at a certain level. So based on that level, then we know how high the post needs to be.
But the structure is going to bend due to its weight.
So that's why we're building it section by section.
Not even steel will bend.
Like I said, we're building it section by section. It's not gonna.
Be one. How do you know
it's not just gonna be one long beam? It's not just gonna be one long beam.
It's going to be connected, right? Yeah. How do you know that they're straight?
Again, we're going to use physical instruments, to do this.
You're going to use line of sight to decide that it's straight along. You're going to sight along the line. How else would you do it?
We're going to use a plumb reference and make sure that all the plumbs are parallel to each other as we go down.
It's up and down, not horizontal.
Exactly.
Right?
We're going to use the plumb is going to be the reference, and staying perpendicular to the initial plumb is how we're going to measure the levelness of the structure.
You're a mile away from the plumb. How do you know how high the supports need to be to make that structure straight and level with the point a mile away from you?
Because it's building it by section. We're not just building a mile off the bat, like having the 2 points meet each other in the middle. No, we're building it from the start.
Sections will sag.
Step by step.
They'll sag though. The sections will sag.
No, they won't. Not with support and accounting for that.
No, they will sag. You don't know anything about engineering. Yes, they will sag.
No, again, it's not going to be 100%. We can account for the small deviations, but again, we're going to build support beams in between support posts.
You could do doing that. You know what you could do is you could just do what they did at what you could do is what they did at LIGO, right? Which they built. LIGO is two 2-mile arm longs at 90 degrees to each other, right? And they're perfectly straight. LIGO is forcing the line. People have already done the force the line experiment for you.
Yeah, and it shows that there's no curvature. All the blueprints
that's not true.
Used to, exactly.
It's false. Right. That's false. That's false. The arms they do not conform to the surface. They're not the same height above. In order to show that the Earth is flat, the arms would have to all be at the same height above the ground at both ends, and they're not. They're not. Well, that's falsifying. That's falsifying the flat Earth, confirming force the line, showing that the Earth is in fact curved.
So you first said that force the line is not possible. Now you're saying it is possible, and you debunked the flat Earth. So it's like
they did it. They did it.
How convenient.
How convenient.
They did it by using surveying equipment to sight, to make the sight. Right?
Okay. Is there any other
rejecting that? You were rejecting that.
Okay. Is there anything that you would want to share that's like the nail in the coffin for the globe before you go, I guess?
The nail in the coffin for flat Earth is going to be in just a few weeks when we see a 24-hour sun in Antarctica.
So that's the nail in the coffin for the flat Earth, and it's going to prove the globe. Yeah. Okay.
It won't prove the globe. It'll provide evidence for the globe. Science can't prove things. Science can only give you increased confidence in the hypothesis being correct, right? So what will you do when the flat Earth is crushed
We're not flat Earth.
next month? Yes, what shape is the Earth?
It's not flat. It's
Not
level.
all the shape.
What is it? What is it? Is it flat or is it round? Which shape is
It's
it?
not flat or round.
Yeah, flat.
Is
is
it flat or round? Well, then what shape is it? What shape is it?
We're not claiming to know a shape. We're saying that it's level.
So the whole, what the Earth is as a whole, that is unknown. So it's the part that we live on, the surface of the Earth we live on, that is level because it has orientation.
Is that by level you mean flat, right?
No,
No.
level and flat are two.
Well, then what's the difference between level and flat?
This line is flat, but not level.
Yeah.
Again, level requires orientation.
So do you think that the Earth could be a level line that's pointed up?
No, the Earth is a level topographical plane because it has orientation because it has motion.
Right. So that's what people mean when they say the Earth is flat. You're just trying to be a little on the outside by using the word level instead of flat. When people say the Earth is flat, they don't mean it doesn't have hills and valleys. They mean that it's flat.
But they also mean that it's motionless. Most people that claim the Earth is flat,
That's
95
what
over
it means.
95, they also claim it's motionless.
Yeah, but that's not what flat means.
Well, flat doesn't have orientation. If
Exactly.
you want to get to what
Flat,
words mean.
yes, but flat doesn't mean it's moving, does it?
It doesn't, but my point is that over 95% of people that claim the Earth is flat also believe it's motionless. It's like a hand in hand.
Yeah, could
People
it
that
be?
claim that-
Could it be a level topographical plane and not moving?
Then that's an oxymoron because level requires orientation, which requires motion.
No, it doesn't. Orientation doesn't require motion.
It requires a force.
Your girlfriend just showed her arm at an incline. Was it moving?
No, but she's connected to the Earth, so we're using the Earth's reference
I'm already
frame.
in contact.
So your arm was not moving, but it was level. Therefore, level doesn't require things to be
It was
moving,
not.
does it?
So when you have a
You
spirit
said
level, for
your arm
example,
was level.
no,
I said it was flat, but not level.
she said it was flat, not level. So this is flat, not level. It's an incline, like you said.
Oh.
Yeah.
So level can only be perpendicular to vertical,
Exactly.
right?
Even on the globe
So
Earth model.
that's
the same thing.
that's false, because when she showed her arm at an incline, her arm was level. It was flat and level, with no part higher than the other, with respect
no, I
to
said
itself.
this is level. I said this is flat, but not level.
Except it's
This is level.
except it's
This is
except it
flat,
is level.
not level. It's not level.
Level means no
Level.
part. Level means no part higher than another, right? And your arm wasn't crooked; it was straight, which means it was level.
No, it means it was flat.
Yeah, obviously, if you have it in an incline, this part's higher than this side. So again, by your definition, which is true, that no deviation in elevation, that proves this is not level. This is at a higher elevation than this.
I mean, in reference to your arm, not to the ground.
But that's the thing, levels and orientation, you need a
Exactly.
reference.
Yes.
When that reference is the vertical. So
Level
if you
just
have it like
means
this is the vertical because we're on Earth. We're experiencing a force, which is the
Do we need to
vertical.
pull up the-
Right,
So
so-
if we have something that's inclined or not perpendicular to that, then we can say that that's not level.
so geometry doesn't require motion. That's what you're saying. You're saying that geometry somehow requires motion. It does not, right?
Orientation requires motion.
Yeah.
I don't know what you're trying to say by geometry.
Orientation doesn't require motion either.
Orientation, let me ask you this, does orientation require a force?
No,
It doesn't?
no.
So something in space or something where there's no force acting on it, it has orientation?
Can I face north and then turn and face south?
Okay, that's a visual that you're just
That's an
looking at.
orientation, isn't it? I'm oriented north, and then it can be oriented east or west.
Let me rephrase that. A physical orientation.
I'm physical. I'm physically
That's a-
I'm physically oriented towards the North Pole. That's
So
a
if you look,
physical orientation.
so if you're looking at the north, does your whole body reorientate relative to that now? Do you have a new plumb now because you're looking at the north?
Plumb has nothing to do with the direction, with the directions on the compass I'm facing. Plumb is up and down.
Wait, so does plumb have anything to do with orientation? Let me ask you that.
Plumb is up and down. That's another orientation. Yeah, I could look up.
Plumb has to do with orientation, right? It's a part of orientation, right?
Plumb means it's following the force of gravity, right?
Okay, exactly. So a force.
Right.
You said it wasn't a force earlier, but now you're saying it is a force, which is kind of weird. But
well, we're allowed to talk about it in classical terms because we're not moving at the speed of light, where relativity comes into play, right? If we were moving at a significant percentage of the speed of light, then it would probably be important to use relativity, but we're not. So we are permitted to talk about gravity as a force.
Right, sure. But again, my point is that when we're talking about physical orientation, again, what dictates up and down, that requires a force.
No, it doesn't. No, it doesn't. No, obviously not. Because up and down is determined by gravity, and gravity is not a force.
Okay. But gravity causes motion, right?
No, it doesn't cause motion, right? When an object is in free fall, it's not accelerating.
But is it moving?
No. The earth, when you drop an apple falling from the tree, the earth is moving up to the apple. From its,
but the earth is moving. The earth is moving up to the apple, but the earth is not expanding, right?
Correct, because space is compressing as much as it's moving upwards. So it's in equilibrium. The earth is in an equilibrium state to the force of gravity.
Of zero, right? So it's a net force of zero.
So it's in equilibrium, right? The normal force is caused by the electromagnetic repulsion of the electrons in the atoms that make up the Earth. That's the normal force.
How does a non-force like gravity affect the normal force of the Earth of expanding?
The normal force isn't caused by gravity. It's caused by electromagnetic repulsion.
And the gravity non-force, right?
Yeah.
How does that affect the normal force? Because that's what you're saying is compressing.
Again, it doesn't. Well, it compresses space-time.
Which compresses the Earth down.
And the Earth is in equilibrium with the force, with gravity.
So a non-force is affecting a force, is what you're saying.
No, it's affecting the matter, the mass of the Earth. It's affecting that. That's how it originates, from the mass of the Earth, and it's in equilibrium with gravity, which is a compression of space-time, and they're in equilibrium with each other.
So if something is in equilibrium, will it be safe to say that it shouldn't move, right? Obviously, that's what you're saying. The Earth doesn't expand, right?
Yeah, it doesn't from our reference frame. It falls from our reference frame.
Okay, if those two forces are at equilibrium, right? Why does a helium balloon go up?
Because it's being squeezed.
But it's at equilibrium.
No, it isn't. It's being squeezed. I said the Earth was.
So what's causing the helium balloon to go up?
It's being squeezed by the air around it.
But the air is at equilibrium with the Earth.
No, it's not. It's not at equilibrium. It's experiencing. It has pressure, a downward pressure. The pressure at the bottom of the balloon is higher than the pressure at the top of the balloon. So there's an imbalance. It's not an equilibrium. It's imbalanced. It's an imbalance. Yes, for the balloon, it's an imbalanced force pushing it upwards because it's being squeezed like a pimple, right? When you squeeze a pimple, you press on the sides, right? Your body, your flesh, right? The flesh is the atmosphere. The atmosphere presses against the balloon, squeezes it, and it goes up.
Okay, so you're claiming that the gravity and the up and the normal force are at equilibrium.
Yes.
But now there's an imbalance with the helium balloon.
Yes, because balloons and the Earth are not the same things.
I know, but the helium balloon, it's affected by a force, right? Because it cannot move on its own, right? What force is causing the helium balloon to go up? And is it the normal force or gravity?
I just told you
gravity?
It's pressure. It's pressure.
And what's causing the pressure in the air?
Gravity, right?
So the downwards flow of gravity is what's pushing the helium balloon up.
No, the air molecules are trying to go down, right? That's pressure. Pressure,
So the air is going down, but it's pushing the helium up. That's what you're saying.
The molecules of the air can exert a force because they have mass and they are moving relative to each other.
Right. So if gravity is able to affect the air, which is more dense than helium, how is it that it doesn't affect helium and able to push it down even easier?
It does affect helium, just not as much.
Push it down like the air?
Because helium has less mass.
Exactly. So it should be affected even more than the air.
No, it should be affected less because the amount is proportional to the mass.
Right. So it's magic. So the gravity splits.
It's not magic.
To the density.
No, gravity affects everything with mass. Helium has less mass than the air around it. Therefore, there's a buoyant force exerted on the balloon, pushing it up.
Right. So this is just your interpretation of the observation.
No, this is middle school. This is middle school physics.
Okay. Can you demonstrate this experiment of gravity pushing the air in one direction, but pushing the helium balloon in the opposite direction?
That's exactly what I'm saying.
So that's what you're claiming.
I'm not claiming that. I'm claiming that air pressure is greater at the bottom of the balloon than at the top.
And I agree with that.
You could measure
that.
You could measure that with a delicate enough instrument to measure that.
Again, but the cause of that, the higher pressure, on the lower, and the less pressure, the higher, that can easily be replicated utilizing motion of a container. Do you have an experiment to recreate those conditions?
It didn't make any sense. So the reason that we have a gradient, we have an air pressure gradient, atmospheric pressure. We have an atmospheric pressure gradient that is caused by gravity.
Okay, I can recreate a pressure gradient utilizing a motion of a container. So I can recreate a pressure gradient. In other words, reorientate. Now,
you mean like
do the same using gravity?
We just observe it. We would just observe it. The pressure at sea level is 14.7 psi, and at the height of a mountain, it's considerably less. So we just measure it, right?
Yeah.
You can do it with a barometer. You can do it with a barometer. You can measure the barometric pressure with a barometer.
I'm not disagreeing with. What I'm asking is, what's the cause of that pressure gradient?
Gravity.
Can you recreate a pressure gradient using gravity?
Well, we're on Earth.
So you can't recreate.
So on Earth, we could measure the pressure gradient on Mars. We have a rover on Mars. I would imagine it has some way of measuring the atmospheric pressure on Mars.
I mean, this is now you're going into Disneyland or like.
You shouldn't have to.
You don't think our Mars exists? Do you think Mars doesn't exist?
It's just a light in the sky. It's just we gave it a name. Mars.
No, it isn't. You can see it in your telescope. It's obviously not just a light in the sky. It's obviously not just a light in the sky. You can see it, right?
Just because you can see it doesn't make it.
What do you mean? You don't think you can? People can see Mars? People have seen.
It doesn't mean it's terra firma.
You can see it, dude.
Okay, that doesn't make it terra firma. How do you
yes, it does. You can see it. You can see the weather on Mars from Earth.
You can see train tracks converging as well. Doesn't mean they are.
I'm not talking about perspective. I'm talking about you can see
the observations.
You can see the weather on Mars from Earth.
Okay, well, that's just your belief.
It's not a belief.
How did you confirm that?
People have been watching Mars for hundreds of years. People have been watching Mars for hundreds of years. You can see the weather. You can see summer and winter on Mars from Earth.
Yeah, I agree. People have been observing Mars for hundreds of years and making assumptions about Mars for hundreds of years. What is
An observation isn't an assumption. An observation isn't an assumption. It's an
If you're making
observation.
claims about the observation, then that is an assumption. If you don't make claims about the observation, then that's not an assumption.
The observation is we can see a light in the sky or something in the sky.
We can see more than that.
The assumption is that it's terra firma.
No, you can see the ice caps on Mars from Earth. What do you mean? What are you giggling about? What are you giggling?
You see ice caps on
Yes.
Mars?
Yes.
Okay.
You can from Earth.
All right.
You're just an ignorant, arrogant little prick.
All right. That's
I mean,
enough.
I'd love to know what she's smoking.
All right, that's enough of her or it, whatever the pronouns are, I guess, right?
It's irrelevant.
So again, I guess I'll leave the stream open for another 5-10 minutes if anybody else wants to join. Again, if you just simply want to come on and share your story, you know, how you came across this topic.
And don't forget staying objective and going back to the conversation, just because a lot of people do this when they see that they can't get to you or challenge you, basically. They always turn to, oh, you guys are just pricks, or oh, you guys just talk shit, or just, but the irony is look at how these conversations go. You give a little grace, you let them say their piece, and you're still a prick.
At the end of the day. Again, yeah. So again, if anybody else wants to join, again, I think sharing, your story, especially because I do share my channel with real people out in the streets, like all of you already know. So a lot of real people do, watch my channel. Maybe not like a whole lot. Not everybody that I share the channel with watches it, but I'm pretty sure people do watch, new people do watch my channel. So again, somebody coming on and sharing how this, how you came across this, can help somebody new, maybe they can relate, maybe because they heard of the topic, it can help somebody out there, So again, don't be shy, again, if you want to come up and share something at the end of the day, it's progression at the end of the day, speaking out, talking about this. It's how this is going to move forward. I know it could be a little bit, intimidating at first, especially being camera shy or, just antisocial. I'm antisocial, 100%,
Likewise.
So me going out and doing these interviews out in the street, to me, is completely out of my element, So, but again, it's not about how we feel, again, because that's how they're controlling us at the end of the day. It's controlling our emotions, controlling what we think, all of these aspects of being, that's how they're able to control our actions, it's by affecting our emotions, So again, this whole, feeling antisocial, not wanting to speak out, it's all part of the psychological warfare that's been going on, It's not, out of nowhere that people are antisocial. People think that, at the end of the day, I know I'm a victim of the system, which is why I'm antisocial, so it's coming out of that comfort zone, that's going to be the hard part. But again, it's needed. It's necessary if you want to share this information, if you want this to move forward.
Yeah, things are not just going to change. You have to be part of you have to change as well and be part of that to lead others or for others to follow by example.
Exactly. Again, if you want to change the world, right, you got to change yourself. At the end of the day, again, we're not trying to change the world. At the end of the day, I'm just literally trying to present simple facts that basically debunk the whole heliocentric model, and then basically, it exposes the government, as the control system that it is.
Yeah, and I don't think we're here to convince anyone per se either. I mean, once you understand it, you can choose, you can believe whatever you want to believe, it's your choice. But as long as you know that it's a belief, then, so be it. But to deny objective reality, demonstrable reality, it just doesn't make any sense.
No. Again, it's about controlling people's emotions. And again, they want to keep people down by just intimidation, bullying tactics, gaslighting, misrepresenting. You know, every trick in the book you could think of is being utilized. You know, that's how they're doing this whole. You know, that's how they're pushing this whole lie. You know, at the end of the day, and again, it's not about the shape of the earth for people that think that they're lying. Just like, what's the point of, you know, them lying about the shape of the earth? You know, like, that doesn't make sense to me. And it's like, it's not about the shape of the earth. It's about getting you to believe something that's not true. In other words, they're getting you to dismiss your own common sense.
Not to trust your own discernment.
Exactly.
Not to trust your own reality or what you
Your own, you know,
your senses.
Exactly, yeah, of your understanding of reality. Again, it's like you said, it's about you not having discernment. Because if you believe in the globe Earth, that shows that you don't have discernment at a fundamental level.
You're just gonna follow whatever anyone tells you to do.
That you think is smarter than you, for example.
I mean, it's already like that. Like, you just throw on a lab coat and suddenly you're like, your IQ went up.
Yeah.
You know, that's what does it for people.
Yeah.
I mean, how many times do people like, well, where's your book? Or put it on a piece of paper, or, you know, and it's just like, it's crazy that you would rather trust that and you need that to be able to understand reality.
Yeah. But that's the thing, they're not understanding reality, they're just believing it. So they rather have these explanations and belief over a demonstration and understanding.
Right.
You know? No, yeah. So yeah, it's pretty bizarre. That again, and it's all been done through psychological warfare. Again, because when it comes to human beings, what makes us different from animals is that, yes, we're the most intelligent. I agree. But when you have human beings trying to control other human beings, again, because we are intelligent beings, you know, the most intelligent, you know, from all animals, you know, and I mean intelligent in the sense of being creative and being able to create. Because obviously animals are super intelligent, you know. When it comes to survival skills, if we're talking about intelligence when it comes to survival, some animals are probably smarter than us. You know what I'm saying? Animals can adapt, you know, pretty quickly. And, you know, so point being is that being the most intelligent humans, you know, when it comes to being creative and, again, being questioning our reality the most, in other words, you're not going to be able to control humans like you do animals, like by force, for example, you know, because, again, human beings will come together, you know, eventually, you know, or, you know, human beings will not allow it, you know, and you know, so how do you control human beings? You do it psychologically. So that's where this whole globe Earth flag comes to play. Not only does it make you dismiss your common sense, it also disconnects you from your true nature. Again, the Earth. You know, we exist within it, you know. So if they could get you to believe that the nature of the Earth is something that it's not, then by default, you're going to believe you're something that you're not, you know, as a human being.
All right, we have someone else, Mr. Spock.
Mr. Spock, all right.
Do you want to verify their YouTube name first, or just Adam?
Here's Adam. Mr. Spock, can you hear us?
Hey, William. Hey, Natalie. How you going?
Oh my God, this is TK. You know what?
Listen, I had to make my one final
wanna...
little guest appearance. Come on, guys.
I don't want to be rude or anything, but like, I'll give you a minute or two. What do you got?
All right. I'm gonna take a totally different approach today, right? I just saw the last like 20 minutes of Brenda and you guys talking, but I've got a different approach for you.
Sure.
Is that cool?
I'll give you a minute.
All right, cool. Listen, one thing that I gather from you guys and from most flat earthers or level earthers, sorry, I'll call it level earthers, is you think that there's this pretty big conspiracy to hide the truth from us all, right? NASA is lying. All the photos are CGI. It's just one big conspiracy for power and control, and it's just Photoshop what they're pushing at us. Is that right?
Sure. It's kind of
Okay.
general,
How many people on Earth, William, do you think are in on the conspiracy? Like, it's not just NASA. How many space agencies are there around the world?
I'm not sure how many space agencies, but not
There's over a dozen, right? Over a dozen. So
I'm going to mute you real quick so I can answer you. So I don't think that all the space people that work for all the space agencies are lying. You only need the astronauts to lie, and maybe a few people that are the head of of NASA, for example, to lie. So everybody else underneath them could just believe what they're being told. So
yeah, I've actually know a few people who work or used to work for NASA, and it's pretty low level, and they're just on a computer screen, and they're not doing.
They're not
anything
lying.
else.
They just
Yeah.
believe what they're told.
So there are literally thousands of people who work together in a coordinated fashion to create satellites, to create rockets.
Okay, I'm going to mute you again right there because you're making a statement there. And the fact is that not everybody works together. I don't know if you knew, NASA is actually very compartmentalized. And it's for that very reason you're trying to obfuscate. You're trying to say the opposite, that they work together, but no, they're actually compartmentalized. And then they put everything else together on a separately,
All data.
So.
All right, here's the question for you then. Who is controlling it all, William? Who?
That's irrelevant.
What do you mean it's irrelevant? It's totally relevant. If someone's trying to control us, shouldn't we know who's trying to control us?
No.
How could we know?
Well, you're saying that the head of NASA is in on it, right? Obviously, and maybe a couple of other people are in on it. Well, who's their boss?
You tell me.
I don't think we're ever meant.
Well, I don't believe there is a
think
boss.
it's
You think
random
there is a boss.
faces.
Well, I think there's definitely people pulling the strings.
Yeah, there's people.
Well,
on it.
which
But we don't
people?
need to know. We don't need to know who they are. All we need to know is that there are lies being pushed.
That's the thing about being so compartmentalized. They put so many faces that they're the face of NASA, or they're the face of it. They're not the people pulling the strings.
Okay. Forget NASA. You know that there are thousands and thousands of astronomers and engineers working at universities, publishing papers, checking everyone's paper, trying to poke holes. The Nobel Prize is awarded for physics every year for people that come up with new ideas that have been tested and so on. So there's this massive body of work that is freely available for everyone to scrutinize, right? People who really understand the stuff can scrutinize it. How come none of these top level IQ people, how come they haven't picked holes in it and gotten themselves a Nobel Prize by proclaiming a flat level Earth?
Simple. People don't bite the hand that feeds them.
Oh, you're joking.
It's like
You're
animals.
kidding. You're saying that every scientist on the planet, every engineer who knows better is simply corrupt. That's what you're saying.
Most, yes, but I'm pretty sure there are people that maybe do speak out. You're just never gonna hear about them.
William, I haven't seen
They're
any
not gonna get
scientists
hired.
driving around in Ferraris and Lamborghinis. It's not like they're getting paid millions of dollars, right?
No, but they paid lots of money for their education and for their degree and for all this. Their whole livelihood's at stake.
Exactly. These people commit their whole life to knowledge, to science, to
So
understanding
why would they go
the
against
Why would
universe.
they? You're missing
You
the
think
point.
they're
Their whole
gonna
livelihood's
be?
on the line. Why would they go against what their whole livelihood?
I'll tell you why.
They're
Because
too
if
far in deep.
I'll tell you why, Natalie. I'll tell you why. Because the people who find something new, who disprove an established idea, are awarded. They're given Nobel Prizes. These people are proclaimed as geniuses. Einstein broke classical physics with his theories. These people are lauded in the scientific community, right? That means that they're
getting
given
incentives for
praise.
lying.
So yeah.
So they're giving they're giving praise for lying. Okay, so that's even more of a reason to lie. I'm gonna be famous now.
Not lying, for finding the truth.
But what if those truths contradict what we know of physics?
Hang on, you're saying
And
that,
they're
that
not
the
truth.
truth is a level Earth. So you're saying that out of all these millions of scientists and engineers, not one of them is going to be able to find the truth.
Maybe they have.
I bet you if they have,
they're gonna stay
they're
quiet.
not allowed to speak on it, or whatever they said gets removed or deleted from the scene.
By whom?
I don't know. I mean, my channel gets messed with as well. Who's doing it? I don't know.
These are the
Well, like you're just assuming that. You're saying that literally every scientist who's smart enough to understand all this at a very high level, much higher than me and you, is staying silent because they're scared or because they want money or something like that. So there's this massive worldwide conspiracy is what you're suggesting.
I mean, you could just say you're assuming that everyone's honest. You know, we can't assume everyone's honest.
No, you're assuming everyone's corrupt or scared.
I'm assuming everybody that believes in the globe Earth is wrong. I mean, it's not even an assumption.
Yeah.
I know that.
And if there's people that have spoken out, I guarantee you wouldn't have heard about it.
Genuine people.
Yeah. So for decades and decades, all these people on their deathbeds, terminally ill scientists who know the truth, remain silent, remain quiet. You think that that's a reasonable thing to believe? That not one person, not one whistleblower who's able to prove it has proven it because they're scared or some controlling body is bribing them or something like that. You're saying
Well,
that the
first of all-
conspiracy is that widespread.
Well, first of all, again, focusing on that is irrelevant, but I'll tell you this, that even if people did speak out in their deathbeds and said these things, who are they? Who's going to cover that story? What news agency is going to cover that and blow it up? So even if they did say it in their deathbed, who's going to record it and make it go viral?
I have a question. How does any of this prove a globe?
Well, you're asking us to believe what you're saying, which goes against
No.
whole.
We're not asking anyone to believe anything. We're just presenting demonstrable reality.
Holy cow! Okay, let's get to demonstrable reality again, then, right?
No, but how did all your questions about NASA and people lying and all that? How did that pertain to the shape? How did that prove?
Well, you guys use that as an argument.
Disprove a level Earth or
Okay, Brenda was saying that we can see Mars, which we can through a very powerful telescope. You can make out a lot of detail of Mars. But
So
you're saying you
no,
laughed at
no,
Brenda.
Brenda.
You literally laughed, saying as if we can't do that. But we can. You can do that. You can buy a telescope.
No, I
and look
laugh at the
Mars.
claims that there's ice mountains or
But you can
glaciers.
see ice glaciers.
There is frozen water on Mars, and that means that there are ice peaks on Mars.
That's
William,
your
if you look at the red planet and there's white patches, what would those white patches be, do you think?
CGI?
No, through a telescope, William, not on photos. If you look through a telescope,
all we know is they're white patches. How are you identifying them as ice?
Even
okay,
if you
forget
could see
that.
it, it's just the light. But
No. I would
All right.
like you to actually prove something. What do you mean forget that? Now you have to prove
spectroscopy,
how you've
Natalie.
seen ice.
Natalie, it's called spectroscopy. When you pass light
fancy
through
word
a
for
prism,
observations?
you can identify the molecular nature of what's producing those wavelengths.
So your
The
proof is
atomic
an
nature.
observation of seeing white patches on Mars.
Well, obviously, it's observation using scientific equipment. You don't want me to go there and collect some and bring it back for you,
so
do
we
you?
have scientific equipment to go to see ice on Mars, but we don't have any other scientific equipment to prove that the Earth is a globe here or any of that.
There is plenty of evidence for that. We have sent up rocket after rocket. There are so many satellites up in the sky right now. You can go out and track them. In fact, you can see the International Space Station.
So observations, more observations. So you don't have any physical proof, just like the rest.
Okay, let me ask you, what kind of physical proof would you be satisfied with?
You really don't know?
A direct physical measurement.
You haven't heard it long enough here?
Yeah, William says a direct measurement of the Earth. But a measurement of what? The diameter?
Water.
The mass, the curvature,
the convexity of water that you claim there is, the curvature of water.
If there's curvature, then the water should be bent.
Okay, so that lake experiment that Will Duffy was talking about is actually a pretty good one, don't you think? Where you get a large lake and you put observers on either side of it.
Okay.
No, not
right.
the docks, not a dock on each side.
All right, I removed it already. To be honest, it's getting late over here. I don't even know if I appreciate you coming on. Again, I don't want to be rude. But yeah, to be honest, I'm not trying to talk circles again. So I guess kind of late over here.
Well, he said that was the last time, so give him one.
Yeah, we'll see.
I know.
So nicely in there. Just kick comes through.
Still hanging out.
All right. All right, if there's anybody else that wants to join, I'll leave it open for like 5 more minutes.
Do you see how they get though when you like just having a casual conversation going back and forth, and now it's their time to provide proof or anything like that, and how they're like, just forget it. oh, let's just move on. Forget that. Let's just move on to the next thing now. It's just, how can you have a conversation this way?
And I mean, they're just jumping back and forth,
Well, just you have to do all the answering, and they don't have to answer anything. But the initial claim is a globe, so you do have to prove the initial claim.
Yeah, your initial premise, which is false.
We obviously can prove our stance and reality and demonstrate it. And so, you guys demand that, but when it's flipped on you have no answers. You run
theories.
You just say it's imagine this, and it's like, if it's reality, you don't have to imagine it. You should be able to demonstrate it.
Imagine an asteroid, for example. Yeah.
Like, you're telling me about the weather on Mars when they told me the other day it wasn't going to rain, and it rained. Like, it doesn't make sense.
Right. So, let me see. Let me just close this. I could go over these.
But it's good. I mean, you let people expose themselves for who they are, and you don't even have to do anything else.
Yeah.
And then after that, you don't have to entertain any more conversations with them.
Again, anybody that disagrees with the motion of the Earth, or that believes objects accelerate down in free fall, either or, again, or if you think there's a more important topic than this, than the shape of the Earth, then please come on and let us know. Again, if you simply just want to share your story of how you came to this subject and how you realize that the Earth is not a globe, that would be great as well. Again, I might question your logic again on the motion of the Earth. But again, this is the opportunity for people, all the trolls, all the motionless flat earthers that are in my comments, every video. Again, this is your chance, and just for future, again, if you want to have a chat, again, these lives are usually going to be, open, even if it's not in the title. You can request a link in the chat, and I'll provide it again for people. Again, I'm not, this is not an echo chamber. Again, this is open to anybody that wants to come up and have the discussion. Again, it doesn't matter whether you have a master's in physics or you're homeless, I guess it doesn't matter. If you want to come up and have a chat about the reality that we all share, then again.
Yeah, I was going to start with imagine, then we might have to cut the loss right there.
Yeah. No, yeah. Let me see if there's any questions or any comments in the chat before calling it. Let's see.
Too nice.
He never looked through a telescope. That's true. I mean, for them to be claiming that they're seeing white patches, like, it's just fucking ridiculous. Like, anybody that's actually seen Mars through a telescope, obviously, it's just a twinkling light. It's just a light. So all of these claims about ice, glaciers, and fucking winds in Jupiter that are fucking hundreds and hundreds of miles per hour, hurricanes, and all this bullshit. Again, they're just baseless claims.
It's quite odd that they're all like just relying heavily on observation.
Yeah. Again, that's all the globe Earth has.
But the requests they make about prove this and let me see a demonstration of this, and let me see, this physical this and that, but they're sticking to solely observations. It doesn't make sense.
Yeah.
But again, you have them on, the known trolls, I guess. You have them on. Let them say their piece. Let them expose themselves. And then let them lose their own cool like they do. And then you don't have to entertain them again.
Exactly. So again, only NASA telescopes. Exactly. Again, you can see mountains, and you can see craters, and you can see all of these things, and water. And you can see water too, but only through NASA telescopes. Yeah, how convenient. Oh, and they cost billions and billions of dollars, so the average person can never afford them. So you just have to take their word for it.
Yeah, I've looked at telescopes before. You can't see any detail like that.
It's just light and light. Yeah.
And again, we're not denying that we can't see lights or whatever you want to call them in the sky. just don't claim you have no way of proving the terra firma.
No, I know. I guess you could say I am a little bit, too nice to trolls, but at the end of the day, I guess it's just the way I am, and I guess that's like the bullies, like, best thing, I guess, to see that people are actually, are not aggressive, right? They'll try to come and bully, right? Again, but again, at the end of the day, again, it doesn't bother me. Again, I stick to the facts, and again, eventually, again, if I do get tired of it, eventually it might change my attitude towards them. So we'll see. We barely started doing these open panels and actually letting in some internet trolls, because I usually have conversations with real people, like you guys see in my interviews in the streets. And obviously, when you're having conversations with real people, then you're gonna get some honesty, even though some people do have push back a lot. At the end of the day, internet trolls are not like real people on the streets. So yeah, having to deal with internet trolls is completely new to me. Mm-hmm. And again, I'm learning as I go at the end of the day.
And I'm nice too, but I'm also the type of person that will stick up for others. So, I can be a little,
feisty,
so I guess, for lack of a better term, but, I tend to give grace as well. Too.
Yeah. Again, I like to give people an opportunity. Again,
that's what I mean.
Exactly.
Grace, give them grace. And then, at some point, though, I do.
Yeah.
Again, especially if there's known trolls, like not that I don't hesitate, but I'm more direct to just call you out.
Yeah. Again, at the end of the day, we don't judge anybody personally. On a personal level, we don't judge whatsoever. Mm-hmm. What we do judge, or what we do criticize, is the claims people make. So again, you're making claims about stationary Earths and globe Earths and claims like this, then I'm gonna attack those claims. I'm gonna show how ridiculous those claims are. And anybody that still continues to make these claims just shows how stupid you really are. Again, and I don't mean that personally. Again, I'm literally talking about these claims, how absurd they are. And anybody that does adopt them and regurgitates them just shows, again, that you're not thinking for yourself. Again, you're just repeating what you're told, which is no different, than globe earthers. Again, if you're a motionless flat earther, for example. So again, this is not personal attack towards anyone. No. At the end of the day, when I'm talking like this, again, I never attack anybody personally. Unless it's trolls in the comments and they're literally there video after video, then I will address them, but.
Yeah, same. If it's a troll, like, again, I usually don't even just attack. I never attack or anything. I just troll them with facts.
Yeah.
That's the type of route that I tend to take.
Yeah, again, trolling with the facts, there's nothing wrong, especially if they're trolling as well.
Yeah, again. Obviously, if it's somebody honest, we do know how to carry ourselves.
Yeah, obviously. Again,
if you guys see the conversations he has with people on the street, they go nothing like that.
If I can still be respectful with obvious internet trolls, then I'm obviously going to be respectful with real people and honest people, especially if you're truly honest and you're new to this, then yeah, I'm going to sympathize with you. I'm going to, I know where you're coming from. I was there too. I believed in the globe earth concept for 24 years of my life, So again, a lot of the students that I speak to, a lot of them are between 18 and 22 years old. In other words, if they were to grasp this subject, they would be ahead of me. Because again, I didn't come across this till I was 24 going on 25. And I didn't even come across the motion of the earth till I was almost 30. Mm-hmm. I'm 33 years old now. And I didn't come across the motion of the earth, how it debunks the whole heliocentric model, the whole idea of gravity being debunked. I didn't come across that till I was 30, So again, all of these students that I'm coming across and presenting this to, they're if they grasp this, they're gonna be miles ahead of us. Miles ahead of us. Because I could not imagine coming across this information, understanding it for myself in my 20s, year alone 20, I could not imagine where I could be now at 33, 13 years later. Like, imagine if I actually knew the truth then, about the bullshit of gravity. Imagine where I would be now, with this.
It would have been nice to have somebody, reaching out like that.
Exactly, around that time. Unfortunately, I didn't come across this whole flat earth thing, this whole false dichotomy till I was 24. And I didn't get a full grasp, of the whole gravity bullshit till I was almost 30, till I was after, it was like when I was 31 is when I, kind of had a better understanding. So again, people are, also 33 in the chat.
I'm talking about the 33. Well, I'm actually 33 too. So.
Oh, that's 333s right there. Bam. That means we're shills now.
For the next 5 months for me.
Yeah.
Of years.
No, yeah. So, no, yeah. And then obviously being in this topic, I'm noticing that, yeah, like Mark is saying, like a lot of people that are realizing this, are in their late 30s, 40s, even 50s, and even older sometimes, that are realizing this. So it's like the older crowd I'm noticing that are kind of like, realizing this. Again, I'm kind of part of that too, like it's the younger generation that are having trouble. And again, it's because of all the propaganda, all the entertainment, all this, all the distractions that the youth have nowadays, right? And so I get why, they're a bit behind, but again, it's going to have to take people like us to go out and, speak to them directly in the real world, again, presenting the facts, sticking to the facts, again, the future is going to be with the youth at the end of the day. Again, we can make a change now. We can try and push for this now, but at the end of the day, the future is going to be for the youth.
Yeah.
It's about what we leave for them at the end of the day. Because obviously what was left here for us from our parents was garbage, and it's only getting worse. So how about we make a change now so that we can leave something better for the future generations, right? How about not be so selfish, right? And sacrifice some of our time to try and push this truth, the truth that's going to change everything. Why is it going to change everything? Because again, if you're trying to talk about politics, you're trying to talk about economies, ways of living, but you don't have common sense, what the fuck are you doing? So again, people that are trying to jump ahead and trying to say that, oh, the shape of the earth topic doesn't matter. Let's talk about poverty. Let's talk about other. It's like, bro, if you believe the globe earth, you have no common sense. So how the fuck are you going to help others in other aspects of their life when you just believe everything you're told? When you just believe everything you're told by the government, how the fuck can you actually help somebody else out? Let's be real. So again, that's why the shape of the earth becomes important, because it has to do with common sense. Again, if you believe that the earth is something that it's not, obviously something that it's not, then that just shows that you have no discernment. You have no backbone. You have no critical thinking skills. So how the fuck can you help somebody else? You can't even help yourself, for God's sake.
NASA does get quite a bit of money.
So how the fuck can you help?
Exposing all this lie, can help in those areas.
Well, I mean, to start.
To start, yeah, because obviously
money is a tool.
Yeah.
That's being used to control us at the end of the day. So again, it could be a step forward, again, exposing all of this, because again, we're not going to change, society's not going to change from one day to another.
Obviously, the goal is to not even have or rely on an economy.
Exactly.
But that's the first step in the right direction.
Exactly. Yeah. So, yeah, let me see.
Masons for sure wear the tats.
No, yeah, it's pretty crazy. All right, so that's pretty much it. So I guess this is gonna be as usual when we do these lives. We're usually, gonna open up the panel. Again, this will be the opportunity for all the trolls. Again, anybody that has any questions, anybody that wants to expose me, right? I've had a lot of people call me a shill, for example, right? And
baseless. Baseless claims.
This is your opportunity. If you want to come up and expose me as a liar, for example, then go ahead,
If you say we don't want to talk to you, we're running from the conversation, I mean, this is the opportunity.
Yeah, because a lot of people would say in the comments, like, oh, you just delete my comments, or you just ban me, and blah, 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 blah.
No one ever takes my questions serious.
It's like, this is your opportunity. It's live, there's no, hiding anything, I'm not going to remove the video after the conversation, Again, this is the opportunity, again, for future too, because a lot of people will come here and tell me, oh, you should go and debate Bro Sanchez or talk to Witsit or talk to all these other characters, right? Well, this is their opportunity. If they're truly interested and, you know, and they're honest, then they can join this, you know, this chat again for future reference, you know, because obviously it's getting late here. We're going to end up calling it. But again, this is opportunity for all of these people, you know, to join the chat and have the conversation. So yeah, I mean,
1:13 in the morning.
yeah. So I guess we're gonna end up calling it now. Again, I mean, thanks for everybody that joined, that you know, that supports the channel, that shares the videos, likes them. You know, at the end of the day, you know, reality is what it is. So, you know, we can only represent it. You know, and understanding reality for yourself is what's going to show you who's actually lying and who's not, whether deliberate or not. You know, because you can be lying and not be doing it deliberate. For example, when I believed in the globe Earth, you know, and talked about aliens and stuff, I wasn't lying. You know, I just believed what I was told and I would repeat it. So again, just because you're lying, that doesn't mean you're doing it deliberately. You know, it just means that you're brainwashed and you're just repeating what you've been told.
Again, we're not glued to, you know, we don't have a bias. We're open to demonstrable reality. So if you think whatever your position is true and you can demonstrate it, please do so. Yeah.
So yeah, we'll leave it at that. And yeah, thanks again for everybody that joined, and we'll see you on the next one. Peace.
Take care.